Hello everyone. So in this video, we are going to talk about what is AWS IAM. So IAM stands for Identity and Access Management. It is one of the important and core service of AWS, which is used to securely control the access of any of the AWS resources. It controls authentication, which is the who part, and the authorization, which is what they can do or cannot do. Now let's say what are the main concepts of AWS IAM. So currently we have four main concepts in AWS IAM. The first is what we call is users. So users are nothing but the resources that has associated credentials and permission. So let's say if you want to access any AWS account, you should have to create a user, and that user will have a credential associated with it and some permissions of certain AWS resources which you want to give an access to. The second is the groups. So groups are nothing but is a collection of IAM users. So if you want to club more than one IAM users, you can create a groups, and rather than providing individual access to each of the IAM user, you can provide the permissions to that particular group. Now, the third concept is we call as roles. So roles are nothing but the entities you create and assign a specific permissions. So let's say you want to access a certain S3 bucket into your AWS, you can create a role, and that role will have certain permissions of that particular S3 bucket. Now, those specific permissions, what you provide to the roles, we call them as a policy. So policies are nothing but that it is a JSON document that specifies the permission to a particular AWS resources. Hello everyone. So in this video, we are going to see how do we create and use users and user group in AWS IAM. So if you have your AWS account, simply log into AWS Management Console, and in the search bar, type IAM. You should be able to see an option of IAM. Just click it to open it. Once you are in the IAM page, you will see different options like user groups, users on the left hand side. So in this video, what we are going to do, we will create two different users and provide a certain accesses of our S3 buckets to those users. So one user will have only the read access on our S3 buckets. The other user will have all the accesses of on the S3 buckets. So to create an users, you simply clicked on users. You should be able to see a create user option. So let's create the first user, which will only have a read access to our S3 buckets. So just click on create user, and let's give a name to this user. So for this one, let's give a name that it is S3 read user, and we will provide this user the access to our AWS Management Console. So we'll click these options, and it will ask you to provide the password. So the password could be an auto-generated password, or it could be a custom password also. So let's click on custom password and provide a password to this user. Now, the other option what you see is this is the recommended option by AWS, where it says that whenever user logins for the first time in your AWS console, it should change the password, whatever the default password we are giving over here. So for this demo purpose, we will uncheck these options and we will click on next. So in this page, AWS is asking us to provide the permissions to this particular AWS user. So there are three different options. One, you can add this user to an existing group, and all the permissions are applied to that particular group. The other option is you can copy the permissions of an existing user and assign to this new user, or you can directly assign a policy or an access to this particular user. So let's click on attach policies directly, and here we will see some of the policies which AWS is already created by default. If you want to create any specific policy, and provide to this user, you can just click on this create policy option and create your own policy. But as of now, we will go with the default policies what AWS provide us. So we need to provide a read-only access to this particular user. So simply type S3 read and you should be able to see a policy with the name of Amazon S3 read-only access. When you open this policy, you should be able to see all the permissions what is given to this policy, right? So in this policy, what we are giving this user is the get, list, and describe access, where user can able to see all the files present into a S3 bucket. You should be able to download those files and describe those objects in the S3 bucket. So simply select this policy and click next. Now you are in the review and create page where you can validate your uh, information, where the user will be whatever the username you have provided, what is the policy or the permissions what you're giving. So this is only the S3 read-only access. Once everything is verified, you click on create users. So once you create it, it will generate a default console access URL for this particular user, the username and the password. Now the AWS recommends to download this CSV file with all this information, because if you don't download this CSV file, you will not be able to download again once you go back from this particular page. So let's download this CSV file for our future references and go back to the user lists. Here you should be able to see the newly created user. So this user is only going to have the read access to your S3 buckets. Now let's create another user which you will provide all the accesses of your S3 bucket. So to create that new user, you simply click on create user option, provide a name to this user. So this is the name we'll provide, where we'll mention that okay, this is S3 all user, which is going to have all the different options or permissions available to it. Then click on provide user access to the AWS management console and provide a custom password to this user. And for this user also, we will uncheck this option to change the password at the next sign in and click on next. Now we'll follow the same process what we have done in the previous user. To set the permission, we'll click on attach policies directly. And this time we will search for S3 full, and you should be able to see a policy which with the name of Amazon S3 full access. So if you open this policy, you should be able to see it is having an S3 star. So all the actions what is currently available in AWS for an S3 bucket, all the permissions are going to be given to this particular user. So this user can list all the objects in S3 bucket. It can download all the objects. It can upload any objects into that S3 bucket. It can delete. So all the accesses what you can think of is applicable to S3 bucket. This user will have all those accesses. So let's select this policy and click on next. And once you verify all the details what you have provided is correct, you just simply click on create user, and it should be able to create your user successfully, and you should be able to see the console sign in URL, the username, and the console password. Let's download this CSV file for this user also. Once you download that, then return to your users list, and you should be able to see both the users successfully created. Now let's try to log in to our AWS management consoles by using these two different users and see what all we can do on our S3 bucket and what we cannot. So first, let's log in with the user which has a read access only on our S3 bucket. So simply sign in out from your current AWS account and log back in And this time we will use the account ID is going to be the same because this is the same account where you have created this user, but your username will be different, and provide the password which you have given at the point of time when you create this user. So once you provide the password, simply click on sign in. You should be able to sign in into your AWS management console with this user. So if you see here, this is the IAM user which we have used to log into this AWS management console. Now if you see, all these access denied what you are getting, because since you have not provided access to this user apart from S3 bucket, you will not be able to view or create any other services. So if you want to test that, if you go back and try to create a SNS here, so simply select your SNS and you provide, you're trying to create a topic. So let's give a topic name test. Click on next. So you'll get a access denied exceptions. That means that this user does not have access to create a SNS topic in AWS. So this is we have validated that apart from S3 bucket, this user does not have any accesses. Now go back to your S3 bucket, open it. So now you are able to see all the buckets here. So that's working as expected. This user can list all the buckets. Now open any of the bucket what you currently have, and in this bucket I have a data.csv file, so I am able to see this particular file also inside my bucket with this user. Now I can also get this file because that's the access I have given, so I can simply click this file and try to download it. I should be able to download this file. But let's say if I am trying to delete this file, so I'll simply go ahead and delete this file, and I'll type this permanently deleted here and click on delete object. I'll get a failure saying that access denied. So I don't have an access to delete this file on this particular user what we have used to log into AWS. So this is working as expected. Now let's go and we will try to upload a file. So simply click on upload, select the file which you want to upload. So this is the file I'm trying to upload into this bucket, and click on upload. So this time also we should be able to get the access denied one, right? Because we have not given the upload access on S3 bucket to this user. So this is working as expected, where you have created a read only user, and with that read only user you are only able to list all the objects in your S3 buckets, and you are able to get those objects out of the S3 bucket. Now let's log in again back to our AWS management console with the S3 user where we have given all the accesses. So simply sign out from this user, log back in, and use the user which have all the accesses. So your account ID would be same, just change the user name and provide the password for what you have given while creating this user, and click on sign in. So now at this point of time, you have logged into your AWS management console with this S3 all user, where this user has all the accesses on S3 buckets. Now if you want to create again an SNS topic with this user, you will not be able to create that because you have not given an access to this user to create a SNS topic. So let's test it out. We'll go to the SNS and click on create a topic, click on next step. You should be able to get an access denied exception here also. Okay, so this is working as expected, that this user only have access on S3 bucket. Now go back to your S3 bucket. Now with this user, you are able to list all the buckets of your S3. Now let's open the one of the bucket, and you could see the objects present in this bucket also. If you want to download, you can download this file also. If you want to upload any file into this bucket, so select the file which you want to upload. So this is the file which I am trying to upload. And when you click upload, since you have given all the permissions to this user, it should be able to successfully upload this file. So this is the file which you have just uploaded. Now let's see if you can delete this file. So simply select this file, click on delete, and type this permanently delete and click on delete object. So this is now successfully deleted the object also from the S3 bucket. So this is working as expected, where you have given all the permissions to this user, and by logging from this user, you are able to perform all those activity to your S3 buckets. Now let's log in back with my administrator role. And when I'm going back to my IAM and go to the users, I could see all both the users created here. Now this is how you can create different users, provide them different level of accesses, and give these users to different users to log into the AWS console and access the resource accordingly as per the business need. Now what is user groups? So users groups are nothing but a collections of different IAM user. So want if you have multiple users created in your AWS IAM and you want to provide a same access to all those different users, so rather than providing individual access to each of the user, what you could do, you create a user group and assign all those users to that user group. So to create a user group, simply click on user groups, and you will see a create group option here. Just click on that, give a name to this group. So let's say we want to create a user group which is with this name S3 group, and we want to assign these two users to this particular group. We'll simply select those users which you want to assign to this particular group, and here you can attach permissions. So this permission will be applicable or applied on the user group. So uh, uh, all the users present in this user group will have these permissions whatever you select over here. Okay, and once you select all those permissions, you can simply click on create user group, and it should be able to create the user group which you want. And if you open this user group, you should be able to see all the users which is present into this user group. So this is how you create users and user groups in AWS IAM, which is going to help you restrict the accesses according to the need of the business. Thank you. So to create rules and policies in AWS IAM, if you already have access to your AWS cloud, simply log into AWS Management Console, and in the search bar, just type IAM. You should be able to see IAM option. Just click it to open it. Once you are in the IAM dashboard, you will see an option of roles and policies on the left hand side. So let's first create the policy which is going to have only the read access to my S3 bucket. So to create a policy, you simply click on policies. Here you will see an option of create policy. Now there are two types of policies currently available in AWS. So if you see the types of policies, one is the customer managed policy and one is the AWS managed policy. So there are certain policies which AWS has already created into your account, and it is managed by AWS. So those are the AWS managed policies. So if you want to use those set of policies, you can simply select the AWS managed policy and use that policy in your role. But if you have a specific need to create a policy, then in that case, whatever policies are created by customer, those are categorized as the customer managed policy. So if you filter the AWS managed policy, you will see all these policies which is already been created by AWS. Now, if you want to see all the policies related to S3, you should be able to see all these different policies. So there is a full access policy on S3. There is a read-only access on the S3. So these are the AWS managed policy. Now, in this specific case, our requirement is to create a policy which is only associated to one particular S3 bucket. Because if you open this particular policy, which is the AWS managed policy, you'll not be able to edit this policy because this is a default policy what AWS has provided. Okay, and here you don't have a scope to change anything based on your specific need. That's why in this video we are going to create a custom managed policy. So to create a policy, you simply has to click on create policy. Now, when you are in the create policy page, it will ask you to specify permissions. So permissions are nothing but the the actions what you want to perform onto a certain AWS services. So in this case, my service is an S3 bucket where I want to create a read-only policy. So for that, uh, you have two options. Either you can go and select the service visually, or there is an option you can edit a JSON object. So when you click on the JSON object, the AWS will provide a default JSON object to you where you have to provide the actions and the resources uh, to the certain AWS services. So in this case, what actions we have to provide is we have to provide all the actions which is related to an S3 bucket. So on the right hand side, if you see, there is an option to choose the services. So here AWS will list all the different services which is currently available in AWS. So we have to search for S3. Now, once you see the S3, you click it and it will list all the different actions what you can perform on an S3 bucket. So actions are nothing but the the thing which you want to do on an S3 bucket. So those could be you want to upload a file, you want to delete a file, you want to download a file. These are the different actions what you can perform on an S3 bucket. So to have a read-only access, uh, we only need to provide couple of actions. So the first is uh, before accessing any file into an S3 bucket, the policy should have a list list action on a certain bucket. So until unless a policy, a role or a policy does not have a list bucket action, it will not able to read anything inside the that particular bucket. So for that, you need to select. So in the list section, you should be able to see a list bucket. So just click in front of action and select that options what you want to choose, and it will automatically populate that particular action into your policy. Now, apart from list, we also want to list the version of the bucket. So simply select that also. It will automatically populate. Now, these are the two options what we need in terms of the list bucket. Now we have to read the file from the S3 bucket. So for that, we need to go into the read access level, and here what we have to do is we have to have an get object action. So just scroll down and you should be able to see a get object. If you want to see any information about this particular action, you just click on info. You should be able to understand what this action is going to perform in S3 bucket. So here we want to have a get object. So I've selected the get object. Now we also want to get the ACL of that object. So we'll select that. So these are the four different actions you need to provide as part of your read only access on your S3 bucket. Now, once you provide these actions, now you have to come back to the resources. So resources are nothing but the specific AWS services where you want to perform all these actions. So in our case, the resource is going to be the S3 bucket. So to add a resource, you simply select on add a resource and click on add. And here you'll have because you're performing that activity on the S3, so it will automatically select that S3. Now here you can either add a bucket or an object, so or all resources. But here we want to include a certain specific bucket on which we want to perform this activity. So simply select the bucket, and here it will ask you for the bucket name. So whatever bucket name you have, just provide that bucket name into this policy. So this is going to be my bucket name where I want to perform this activity. So I'll simply write down the bucket name and click on add resource. Now this is my bucket ARN where I want to perform all these actions, and the effect is going to be the allow. So there are two options you can have in the effect, whether you're planning to allow all these actions on these resources, or you could have a deny option here also. So these are the two options what you could provide as part of the effect section. Now in terms of, so this is the bucket where you are going to provide the list bucket action to all the to this particular policy. Now to read anything inside the bucket, let's say inside the bucket you will have different objects, different folders where you want to read these or get those object action. So you have to add another ARN which is going to be after this bucket. Anything which is present in this bucket should have the get object or get object ACL action. Okay, so this is your complete policy which is going to allow only the read access to your specific bucket, which is this bucket, and all the object. Anybody who's using this policy should be able to get all the object inside this bucket. So once you complete your policy, you simply click on next, and here it will ask you to provide the policy name. So let's provide this policy a name where we can see, okay, this is only a S3 read access policy. Okay, here you can see what all you have given as part of the permission to this policy. So we have services as S3, and the access level is list and the read. Okay, so once you verify everything, you just click on create policy. So now your policy is created, and if you search it, you should be able to see this policy, and the type is defined as the customer managed. It's not an AWS managed, it's a customer managed policy. And if you open this policy, you should be able to see whatever you have provided in this particular policy. So now my policy is created. Uh, I can use this policy when I create a role. Okay, so let's create a role. So to create a role, you simply click on the left side if you see our option of roles. So simply click on roles, and here you will get a list of all the roles you previously have created. So to create a new role, you simply select the create role option here. Now it will ask to select the trust entity. So there are 5 different options what you have. So the first is AWS services. So do you want to use this role uh, to allow any AWS services like EC2, Lambda, and others to perform any actions on this account? If you want to do that, you simply select AWS services. If you want to create a role which is going to access this account or any other AWS account, if your use case is something like that, you simply select this option and create your role, and then you'll have these 3 different options based on your business need. But as of now, what we have to do, we have to create a role where this role will be used by a Lambda to access the file setting on my S3 bucket and perform some activity on that particular file. So let's select AWS services, and here you will select the services or use case. So I'll simply select Lambda and click on that. So once I click that, I'll click on next, and here this will ask you to add the permission. So as part of the permissions, either you could attach a AWS managed service policy to this particular role, or you can attach a customer managed policy also. So as of now, what we have to do is like we have to attach the policy which we have created, and that is the policy which is the S3 read policy. So simply search that name over here. You should be able to see that policy what you just created. Click on that policy and click next. Now it will ask you to provide a role. So let's provide a name to this role. So we'll give it S3 read access role. Okay, description is saying that okay, Lambda function, uh, it allows the Lambda function to call AWS services on your behalf. The services is now S3 bucket here, and it will show which policy we have attached to this role. Now everything is verified. Click on create role. Okay, so there is a name already exist. So let's give a name here and create role. So once you see this role is successfully created, where AWS Lambda is going to use this role to access an S3 bucket. Now this is the role which is going to have only the access, which is the read access on my S3 bucket, where if I use this role in my Lambda function, it should only be able to read the files or objects from this bucket of S3. Now let's create another policy which is going to have the all access. So to create the policy, simply click on create policy. Here we will select the services which is going to be the S3. Click on JSON. So once you are in the JSON, you select the services which is S3 here. Now under the S3, what we are going to do as part of the action, we are going to give all actions. So every actions which is available as part of my S3 bucket, I'm going to give this policy all those actions. So simply select all actions, and if you see it puts an S3 colon star. That means that all the different actions which is available to S3 is given to this particular policy. Now as part of the resources, simply click on add resources, select the services as S3. Here we will select the bucket and then give the bucket name where we want to provide this action. So simply select the same bucket which we have selected in the other policy. So this is the my bucket name and click on add resource. Now here also you need to just copy this one, and you will also want to notify that anything inside my bucket, this policy should have access to perform all the actions, right? So the first line is for the bucket, and the second line is for everything inside that bucket. So once your policy is completed, you simply click on next and give this policy a name which is going to be S3 all access policy. Here you will see the service is S3, and here the access level is it is having the access of list, permission management, read, write, everything. So once you verify that, click on create policy. So your policy is successfully created, and you can just verify that by searching that policy over here. And if you expand this policy, you should be able to see this is the permissions what you have given to it. Now let's create another role which is going to use this policy. So click on role, click on create role, and here simply select the AWS services, and the use cases would be Lambda. So select Lambda and click on next. And here we will search for the policy which we just created, which is the S3 all access policy. Simply select the policy, click on next. Okay, now it is asking you to provide a name of this role. So simply give S3 all access role new. and you verify that okay, this is the policy which you have assigned to this particular role, which is S3 all access. Once you verify everything, just click on create role. So now your role is successfully created over here. Now let's go to our AWS Lambda and see how we can use these roles and these policies, and by using these roles and policies, how the Lambda is performing while accessing the data from my S3 bucket. So first let's open our S3 bucket. So once you are an S3 bucket, just look for the bucket which you have provided as part of your roles and policies. So this is the bucket where I have a file which is the data.csv. So what I'm trying to do is, by using the Lambda function, I'm trying to access this file from my S3 bucket, which is this one, by using two different roles. One which only has a read access on this bucket, and one role which has all the accesses on this particular bucket. And we will try to see what all we are doing as part of our Lambda function. So to see that, simply open Lambda. So in the search bar, if you type Lambda, open the Lambda. And here I have already created a function which is S3 lead Lambda. So if you check the code, what I'm trying to do here, so this is my Lambda function which I am already created, and I have a code which uh, where what I'm trying to do is, so this is my code. Okay, so this is my Python code, and this Lambda is running on a Python. So what I'm trying to do is, like, I have defined this is my bucket, which is the Academy training bucket, and this is my source file, which is data.csv. So what I'm doing I'm reading this CSV file uh, and creating a data frame out of it. And once my data frame is successfully created, what I'm doing is I'm writing the same data frame to a CSV file here. And then once the CSV file is written, once the data of this data frame is written to CSV file, I'm taking that CSV file and trying to load this CSV file into the same bucket with a different name, which is the lambda underscore data.csv. So this code is going to read the data from my bucket, and the data is going to come from this data.csv. Once I read the data, I'll create a data frame. Once the data frame is successfully created, I am again writing that data frame into a CSV and writing back that CSV as lambda underscore data.csv to the same bucket. Now, there are two actions what we are doing in this particular Python code. One, we are reading the data, and one, we are writing the data. So now let's use both the roles one by one and see how the Lambda is behaving. Now, the first, we will use the role which is only going to have a read access. So to assign that role, we come to the configuration of the Lambda, and here if you see there is a role. Now let's edit this, and here it is asking you to provide the role through which this Lambda is going to run. So this is the use of a role in AWS, where you can assign that role to any of the AWS services, and by using that role, that particular service will call different AWS services. So in this case, my Lambda is using this role to call an S3 bucket and then trying to read the file from that S3 bucket. So let's go and select the role. So first we will select the role which only has the read access. So this is the role S3 read access role new. So select that role and click on save. Once you say save, you're able to see that okay, this Lambda is now going to use this role to execute the code what we have written over here. Now let's deploy this code. Once the code is successfully deployed, then we will test this code. So to test it, you simply click on test. and let's see what is happening. So now if you see, this is the log coming from the Lambda Python code, where what this code is able to do, it is successfully created the data frame. That means it was able to read the data from the file which is sitting on my S3 bucket, which is the data.csv. So my action which I have given to my role to get the file from S3 bucket is successfully completed. But the second action which it was trying to do, it was trying to put the object once it creates the CSV file in the same bucket. So while doing that particular action, which is the put object action, we got an access denied because the current role what we have used does not have the access apart from a read access, and that's why you got this error. Okay, so this is how we are restricting the access on any AWS services with the help of rules and policies. Now let's go back again and change the role to the role which has all the access. So come back to your configuration, and in place of S3 read access only, what we are going to select is all access role now. Okay, once you select that role, click on save. Now you selected the role. Now let's go back again and test this code. Now we are hoping that at this point of time, your Lambda should able to read the file from that S3 bucket, perform the data frame, then write that data frame to a CSV file, and then write that CSV file to the same S3 bucket. So let's click on test. So once the test is completed, you'll see this particular role was able to read that file. It created a data frame. Once the data frame was created, it created a CSV file, and then it successfully write that CSV file again back to your S3 bucket. Now to verify that, we go back to our S3 bucket and click on refresh. You should be able to see this file, which is the lambda underscore data.csv. So by using the role which had all the accesses on S3 bucket, we were able to perform uh, the read access and the write access through this lambda function. So this is how you can create different roles, and those roles will have different policies based on your business requirement, and then restrict the access on any of the AWS services while accessing other AWS services. So this is the use of roles and policies in AWS IAM. Thank you.
What is Amazon S3? Amazon S3 is a simple storage service in AWS that stores files of different types like text, photos, audios, and videos as object, providing more scalability and security to it. It allows us the users to store and retrieve any amount of data at any point in time from anywhere in the web. Now, what is Amazon S3 used for? The first is we use S3 as a data storage because it acts as the best option for scaling both small and large storage application. The second, what we use mainly S3 for is a backup and recovery. So many organizations are using S3 to back up their critical data. We also use S3 as while hosting a static website. So Amazon S3 helps in storing HTML, CSS, and other web content from users and developer to allowing them for hosting static websites. And the last, what we use S3 for is big data analytics. So Amazon S3 is considered as a data lake nowadays because of its capacity to store large amount of both structured and unstructured data. And it also offers a seamless integration with other AWS analytics and AWS machine learning services. Now there are two concepts in Amazon S3. The first we call as S3 bucket. So data in S3 is stored in a container which we call as a bucket. So each bucket will have its own set of policies and configurations that enables the users to have more control over the data. One important point over here is that bucket name must be unique. The other thing we talked about is S3 objects. So fundamentally, any entity which you stored in a bucket, we call as objects. You can store as many as object you want. The maximum size of an AWS S3 bucket is 5 terabyte. Now in this topic, we are going to discuss about creating and configuring a bucket. We will upload some objects inside that particular bucket. We will view the objects what we have uploaded into the bucket, and then we will play around those objects. Like we will copy that object from one bucket to another. We will move that object from one bucket to another. Now let's create a bucket.
If you already have an AWS account, simply log into that particular account and you should be able to see this particular page. In this search bar, you'll simply type S3 and you should be able to see this particular option. Click on that. You will land to the page of Amazon S3. If you already have created few of your bucket, you should be able to see this particular page where you see an option of create bucket. If this is the first time you're creating a bucket inside your AWS account, you should be able to see this particular page, and here you will see an option of create bucket. Now at both the places, simply click on create bucket, and you should be able to see this particular page where you have to pass all the configurations while creating your Amazon S3 bucket. Now the region is going to be the default, and this is the region where your AWS account is being set up. The second option is it talks about bucket type. So you have two options, general purpose and directory. In most of the cases, we select the option of general purpose. So have that as a default. Now it is asking for a bucket name. So one of the criteria while creating an S3 bucket that it should have a unique name. Now you cannot simply give any name because it is always going to throw an error that particular bucket is already exist in AWS account. Because since all the buckets are created at a global level, it is going to search that bucket on a global level, and if that bucket is already existed in other regions of other AWS account, it is going to simply throw an error that this bucket is already exist. So take an example that if I'm going to give a generic name like demo and try to create this bucket, I'll get an error that this bucket is already exist with the same name. So let's try to give a unique name. So I'm going to give a unique name like the Academy Training Bucket. Now, if you want to copy the settings of an existing bucket which you have already created, then you can simply select that option here and select and export all the existing setting of that bucket and apply it to your newly created bucket. But as of now, this is an optional, so we'll simply skip it. We'll keep the object ownership as default, as disabled. Also, the next configuration is block all public access. So by default, AWS recommend to block all the public access on your S3 bucket. So we'll keep that as a default. Now we have a bucket versioning. We'll keep that as a disabled. So bucket versioning is nothing but it's an option of keeping the multiple variants of your objects in the same bucket. Let's say you have an already existing objects stored into your bucket, and if your versioning is enabled and you are uploading the same file again, what AWS S3 does, it creates another version of that particular file. So at any point of time, if you want to go back and access that particular version of your file, you can simply go there and retrieve that file if your bucket versioning is enabled. The tag is optional, so keep that. We'll keep the default encryption as server-side encryption, which is the S3 managed key option. And now let's
click on create bucket, and it should be able to create a bucket for you into your S3 account. Now simply, if you see it, so this is the bucket what we have created. Now if you click on that, you'll be able to see all those options of that particular bucket what you have created. Now you want to upload few of the objects inside the file, inside the S3 bucket. You'll simply click on upload here. So you click on upload, and then it will ask to add all the files you want to upload inside this particular S3 bucket. So click on add files, and as we discussed that S3 can store any type of file. um, it could be a text file, PDF file, audio file, video file, HTML file, right? So I have different files over here. I'm going to select all those files and click open. So it will select all the files which I'm trying to upload in this particular bucket. Okay. Now simply click on upload. It is going to upload all the files which I have just selected. So let's wait for a few seconds, and if you go back, all the files are being uploaded into your S3 bucket. Now let's say you want to categorize all these different files what you have uploaded into an S3 bucket to different folders. So we have an option to create folder. Simply click on that and give the name of that folder. Now let's say you want to have a text folder where you want to move all your text file to that particular folder. So simply give a name of as text, keep all the options as default, and click on create folder. It should be able to create a folder with the name as text. Also, if you want to create another folder where you want to store your image files, so let's click on create folder and give the folder name as image. Click on create folder. It should be able to create another folder with the name as image. Now you want to move your text files into your text folder and your image file into your image folder. Now how do you do that? So there is an option uh, of copy and move. If you click on actions, you'll see two options of copy and move. Since this is disabled because you have not selected any of the object which you want to copy or move. So if you want to enable them, you simply select the files which you want to copy or move. So I want to move all the text files into my text folder. So I'll simply select all the files, and then I can see that option is now enabled. Now, if I want to copy, I'll simply select the copy option. If I want to move, I'll simply select the move option. So in copy option, what S3 is going to do, it just copy that particular file inside that particular folder. It will not move the files from your current location. In terms of, if you select the option of move, what S3 is going to do, it's move those files from their current location into your destination location. So we want to move these files, so simply select a move, and it is going to ask what is the destination where you want to move all these files. So I'll simply click on browse S3, and I want to move all these files inside my text folder. So I'll simply select that folder and click on choose destination. So it will show that this is the location where you want to move all those files. Keep all the options as default and click on move. So once the process is completed and you go back to your folder, you should be able to see that all the files what you have inside your bucket is now moved to this particular folder, which is the text folder. Now, if I want to move this image folder, so I'll simply, this image file, I'll simply select that file, click on action, click on move, and then browse to that particular location, which is this, click choose destination and click on move. It should able to move my image folder to my image file to my image folder. So now If you simply open that, you should be able to see that particular file inside your image folder. So this is the process through which you can copy or move your files from one location to another. Now let's take a scenario where we want to move a set of files or a folder from one S3 bucket to another. What we have to do is simply select the folder or the files which we want to copy or move. Go to the Action tab and select the options based on your requirement, whether you want to copy it or move it. In this scenario, let's think that we want to copy this particular folder from this particular bucket to another bucket. Once you click that, it will ask for the destination where you want to move this particular folder. Click on Browse S3, go to the list of buckets what you have, and select the bucket where you want to move this particular folder and the content of the folder. So this is the bucket where I want to move it. Once I select the bucket, I'll click on Choose Destination. Let's keep all the options as default and click on Copy. Once the copy is successful, you close it and go to the bucket where you have moved this particular folder and the content of that. You open that bucket and you will able to see that particular folder and the content of that folder has successfully moved a copy to a new bucket. Now let's take a scenario where you want to remove certain objects or certain folder from your existing S3 bucket. So in that scenario, let's take an example that you want to remove this particular file from this particular S3 bucket. So you simply select that particular object. Once you select it, you will able to see a delete option here, which will be enabled. You click on that, and once you verify that okay, that's the correct file which you want to delete from this particular bucket, AWS will ask to type this particular sentence, which is permanently delete. You copy that and put into the box, and your delete objects option is enabled. Now click on that. Your object will be successfully removed from your bucket. So this is how you removed a particular file from your bucket. Let's take a scenario where you want to remove a certain folder from your bucket. So you'll follow the same approach. Once you click that particular folder which you want to remove it, you will see that your delete option is enabled. You click on that and follow the same approach where you type whatever AWS has asked for in the box. Once you type that, your delete object option is enabled. You click on that. Your folder will also be removed. Once you close it, you'll able to see that folder has also removed from your bucket. Now, if you want to see the properties of the object what you have uploaded into your S3 bucket, you simply select that particular object, and you should be able to see all the properties associated with that object. You'll see owner, who is the owner of that object, in which region that particular object has been uploaded, when it was last modified, what is the size of that object, what is the type, what is the URI. So URI is nothing but Uniform Resource Identifier. This is being used in any of the AWS services if you want to access this particular object. You can also see the URL of that object. So if you want to access that particular object on a web, you can simply use this URL to access it. Now, if we click on the permissions, this is going to show all the permissions which are currently enabled on that object. Now, if you want to see all the versionings of that object, you click on versions and it will show all the different versions of the file. Currently, if your versioning is disabled, it will not show all the different versions. But if you have enabled the versioning on in your bucket, if you upload a new file, it should be able to capture all the different versions of that particular object. Now, if you want to download the file which you have uploaded into your S3 bucket to your local machine, what you simply has to do is select the object which you want to download, and you will see an option of download into the menu. You click on the download, and it should be automatically being downloaded to your local machine here.
Hello everyone. In this topic, we are going to talk about what is S3 replication. S3 replication is a fully managed feature available for Amazon Simple Storage Service customers. It can automatically replicate S3 objects from one bucket to another, which is going to help you reduce your cost, protect your data, and achieve compliance with regulatory requirements. Currently, there are two options available as part of your S3 replication. One is cross-region replication, which we call as CRR. The another one is same region replication, which we call as SRR. Now let's see what is cross-region replication. If you want to replicate your objects from your source bucket and your destination bucket, and consider both the buckets are available at two different regions. So if your source bucket is available in one region, and your destination bucket is available in another region, and if you want to replicate the objects between both of these buckets, you have to enable your cross-region replication, which is CRR. What is same region replication? If your source bucket and your destination buckets are only available in the same region of AWS, then you have to enable SRR, which is same region replication, to copy or replicate the object from your source bucket to destination bucket. Now let's see how do we create replication on AWS S3 bucket. So for that, if you have an AWS account, log into your AWS account, and in the search bar, search for S3. Once you see the option of S3, click to open it. Now in this step, what we are going to see is how do we do a same region replication. So for the same region replication, your source bucket and your destination bucket needs to be in the same region. So as you can see, my current region is North Virginia. So now I'm going to create first my source bucket, and then I will create my destination bucket. So to create a source bucket, you click on create bucket. As you can see, the current region what I have is North Virginia, US East. Now let's give a name to the bucket. So it needs to be a unique name. So we can give a unique name like the Academy SRR source bucket. So this is the name of my source bucket. Now, one of the important factor in replication is that you should have your versioning enabled on your bucket. If your versioning is not enabled on your buckets, the replication is not going to work. So for that, we have to enable the versioning. So let's click on enable to enable the versioning, and we will keep all the other configuration as default, and then click on create bucket. So once the process complete, you should be able to see your source bucket, which is we have created for same region replication. Click and open it, you can see the bucket. Now let's create another bucket, which is going to be my destination bucket for the same region replication. So I'll follow the same approach. I'll click on create bucket. I'll have my region as North Virginia, US East. I'll give the name of my bucket as the same, and here I will give in place of source, I will give destination, and we'll keep all the configuration as default, but click on versioning, and we will enable the versioning on this particular bucket also, and then click on create bucket. Now if you see my source bucket and my destination bucket both has been created successfully. Now let's open both of the buckets one by one. Okay. Now what I'm going to do is I'm going to upload a file in this particular bucket. So I'll click on upload button, click on add files, and I'll select the file. So what I'm doing is I'm uploading a image file here. So this is the image file which I am uploading it. We'll keep everything as default and click on upload. Now this particular image file is now being uploaded to my source bucket. Now if I go back to my destination bucket, I don't see this particular file yet uploaded or replicated into my destination bucket because we have not created the replication rules. So now to create the replication rule, I have to go back to my source bucket, click on management, and you see option of replication rules. So I'll click on create replication rule. And this is, it will ask for a rule name. So we'll give the Academy SSR replication. You can give any suitable name, and we'll keep the status as default as enabled. Now it will ask for the source bucket. So source bucket is going to be the same from where we are creating it, this particular replication rule. And the other option is to choose a rule scope, whether you want to apply this rule to a limited scope. If you want to apply this replication only from a particular folder, you can give a folder name over here in the prefix. But if you want to apply this particular rule to all the objects which is being uploaded to this bucket, you will select this one. So as of now, we will click on apply all buckets. Now it will ask for a destination bucket. Now we have to choose the bucket in this account, or you can choose a bucket into another account also. So our current destination bucket is in the same account. So we'll click on browse S3 and we will select our destination bucket, which is this one. So we'll select that and click on choose path. Now my destination bucket is also created, selected. Now the next option is to select a IAM role. So IAM role is going to help you put the policies, which is going to help the replication rule to copy the or replicate the object from my source bucket to my destination bucket. So as of now, we don't have any IAM roles created. So what we will do, we'll select a create new IAM role. So as soon as this particular rule is created, the AWS will automatically create an IAM role with the correct policies. Rest everything we will keep as default and click on save. So once it created, it will ask whether you want to replicate all the existing object or you don't want to. So as of now, we will keep the default one and click on submit. Now if you see, the replication rule is now created. Now if you go back to your source bucket and let's try to upload another file and see if that is being replicated to my destination bucket since the rule is now created. So I'll click on upload, select the same image file which I am trying to replicate to my destination bucket and click and upload it again. So once the process is complete, now you can see the latest version of that particular file. Since the versioning is enabled into my source bucket, I can see all the different versions of the file which I have uploaded. So for that, you click on show versions and you can see this was the previous file which we had uploaded. And this is the new version of that particular file, which is the current version. Now let's go back to your destination bucket and try refreshing it. You should be able to see the object within some seconds being uploaded to your destination bucket. Now you can see this particular object is now being replicated from your source bucket to your destination bucket. Now for that also you'll click on show versions and it should be able to see the current version. So if you see the previous version which we have uploaded into our source bucket had a version ID start with B, and at that point of time we did not have the replication enabled on this bucket, so that particular object was not replicated into my destination bucket. But if you see the current version of the file, it is n start with n, and if you go back to your destination bucket, you can see the current version which we has been replicated to our destination bucket is the latest version. So that's how you can enable a same region replication on two different buckets on AWS S3. Now let's see how do we do the cross region replication on AWS S3. So one of the important point in cross region replication that your source and your destination bucket needs to be available into two different regions of AWS. So for that we need to create the buckets. So what we are going to do is we will create our source bucket into one region, and we will create our destination bucket into another region. So let's create the source bucket first. So what we are going to do is we'll click on create bucket, and currently my region is US East North Virginia. So this is the region for my source bucket. So now I'll give the name of my source bucket, which is going to be CRR source bucket. So this is going to be the name of my bucket. Now we will enable the versioning on this particular bucket, as that's the requirement we have for replication. So we'll click on enable, and we will keep everything as default and click on create bucket. So now you can see your source bucket is successfully created, which is created into US East North Virginia region. Now we have to create the destination bucket, which is going to be into a different region. So for that, let's change the region of our AWS account, and we will select the, let's say, Canada region. So once we change the region, we will create our destination bucket. So for that, we will click on create bucket. And if you see, the region is now Canada Central. Now we'll give the name of the bucket, which is going to be destination bucket. We'll keep everything as default, and we will enable the versioning on this particular bucket also. And then we'll click on create bucket. So now my source bucket and my destination bucket for my cross region replication is successfully created. The region for my source bucket is US East, and the region for my destination bucket is Canada Central. So now let's open both the buckets one by one. So we have our source bucket and we have our destination bucket. Now let's follow the same process what we did for the same region replication. We will try to upload one file, and this I'm uploading a CSV file. Click on upload. So now you can see the file is successfully uploaded to my source bucket. When I go to destination bucket, I'll not able to see the file because the file is not replicated yet, since the replication rule is not created. So to create the replication rule, we come back to our source bucket, click on management, and go to the replication rule section and click on create rule. Now let's give a name to this particular rule. We will keep the status as enabled. And as you can see, my source bucket is this one, and the region of that particular bucket is US East North Virginia. Now we'll select the option of applying this rule to all objects in the bucket. Now we will select the destination bucket. So our bucket is in this account. So we'll select this option and click on browse S3. Now we'll select the destination bucket, which is this one what we have created, which is in the Canada region, and click on choose path. So now our destination bucket is also created, selected. Now we need to create an IAM role. So as we don't have any IAM role, we will click on create new IAM role and keep everything as default, and we will save this replication rule. Once you save this, it will ask that whether you want to replicate all the existing object or you don't want to. So we'll keep that as default and click on submit. So once you submit it, your replication rule is now successfully created. Now you go back to your source bucket and we will try to upload the same file again and see if that is successfully being replicated to our destination bucket. So we'll click on upload, click on add files and select the same file again, click on open and click upload. So once the file is successfully uploaded, now we can check all the different versions of this file by simply selecting show versions, and you should be able to see different versions. So this is the first version of the file which we had uploaded before the replication rule was created, and this is the version of the file which we have uploaded after the replication rule is created. Now we go back to our destination bucket and try to see if our file is being replicated or not. So it will take some time because this is a cross region replication what we have done. We'll try to refresh it. After some time, your file should be automatically replicated to your destination bucket. So if you want to check the version of this particular file, you will simply click on show versions, and this is the version which has been replicated from your source bucket to your destination bucket. So to verify that, if you go back to your source bucket, this was the version ID which we had uploaded before creating the replication rule, which start with 7. And this is the current version of the file which we have uploaded after creating the replication rule, which start with C. So if you see in your destination bucket, you could see the same version file has been uploaded or replicated from your source bucket to your destination bucket. So this is how you can create a cross region replication between two different buckets sitting in two different region of AWS S3. Thank you.
Hello everyone. In this topic, we are going to discuss what is versioning in Amazon S3. Versioning in Amazon S3 is a means of keeping multiple variants of an object in the same bucket. You can use the S3 versioning features to preserve, retrieve, and restore every version of every object stored into your buckets. Uh, Versioning enabled buckets can help you recover objects from accidental deletion and overwrite. Now, an S3 bucket can be in three state. It it could be in unversion state, which is by default. It could be in version enabled state, or it could be in version suspended state. So when a user creates an S3 bucket, by default the bucket will have the unversion state. And once a user enable the versioning of a bucket, it cannot go back to unversion state. But one can suspend the versioning of a bucket after it has been enabled. Now let's try to understand the versioning with an example. So let's take an example that you have two buckets. One is in the unversion state and another is in version enabled state. Now you have a file which is data.csv, and once you upload that file into your bucket, what it does, it generates a key ID for that particular object. So in this example, if you see, the key ID is 112. Now that's the original state. Now what happens that you updated few records into that file and you are again trying to upload the same file into your same bucket. So in the updated state of that particular file, if your bucket is unversion, what S3 is going to do, it will update the already existing file because the name of the file is same, and it generates a new ID which is 113 in this example. So this is going to happen if your bucket is unversion state. You will not be able to, you will override the the previous version of that file if you are uploading the same file again into your bucket. Now think about the same approach in a version enabled state. So in the original state, when you upload the data file into your bucket, it will generate a key ID which is 112. But if there is an update happens on your file and you are trying to upload the same file again into the same bucket, and that bucket is a version enabled bucket, what S3 does, it creates a new version of that file and assign a new ID. So if you see in your S3 bucket, you could see the previous version of the file, which is the key ID is 112, and you could also see the new version of the file, which is going to be the key ID 113. So that's the major difference between your unversioned state and version enabled state of your S3 bucket. In the version enabled buckets, you should be able to retrieve all the previous versions of your file which you have uploaded. So now let's see how do we perform the versioning on our AWS S3 bucket, whatever we have discussed till now. So for that, if you already have your AWS account, just log into that, and in the search bar you search for S3. Once you get the S3, just click it to open it. So for this exercise, what we will do, we will create two buckets. One where we have the versioning disabled, and the other one where we will enable the versioning, and try to upload the files to see the behavior of both of the buckets. So let's create first the bucket where our versioning will be disabled. So for that, we click on create bucket. We'll give the name of the bucket, and this should be a unique name. So let's give the name as where we will have the prefix as unversioned. Uh, let's keep all the configuration as default, and when you scroll down, this is the place where you enable or disable the versioning on your bucket. So by default, AWS keep this option as disabled, so we'll keep this as the default. Scroll down, keep everything as default, and then click on create button. So your bucket should be successfully created. You can see this bucket which has created as unversioned bucket. Now we'll create another bucket where we will enable the versioning. So let's click on create bucket, and this time we will give the name of the bucket where we will have the prefix as versioned. Now scroll down, and in the bucket versioning section, what we will do, we will enable the bucket versioning, and we'll keep all the configuration as default and click on create bucket. So once both of the buckets are created, you can see over here. So one is unversioned bucket, another one is version bucket. So now let's open both of the buckets one by one. We have now we'll try to upload a file. So this is the sample file what I have, where I have two columns called employee ID and employee name, and we will this is the original file which we are going to upload for the first time in both the buckets. So let's upload. So currently we have 4 records over here. So what we'll do, we'll go ahead and click on upload and add the file which we already have. So we'll select that file, which is the original file. So this is the file which we are trying to upload, and currently we are uploading into unversioned bucket. We'll click on upload button. So now the file is successfully being uploaded to your unversioned bucket. You see the timestamp is 1811 and the size of the file is 46 bytes. Now the same process we will apply on the version bucket. So we'll click on upload, select the file which is the data file which we are trying to upload. Once we have selected the file, we'll click on upload button. Now if you see, both of the files have been successfully uploaded. and the size of the file is 46 byte in both the files. Now you go back to your unversion bucket, click on the file, okay, and you see a option of versions. So if you come over here, you will see that since the versioning is not enabled on this particular bucket, you will not able to see any of the versions. But if you do the same activity on the version bucket, you'll click on the file, go to the versions, you'll see there is a current version of the file, which is the one which you currently have uploaded. And the size of the file is showing us 46 bytes. Now, let's make a change in this file where what we will do is we'll add another row. So this is an updated file. And since the name of the file has not changed, we will try to upload the same file again and see the behavior in both unversion and the version bucket. So we'll go back to the file and click on upload and add the new file where you have just updated a new record. So we'll select that particular file. The file name is same. Only thing is that there is an addition of a new record into that file. You click on upload, and this is we are doing on the unversion bucket. So click on upload. Once the file is successfully uploaded, you will see the timestamp of the file has changed. Previously it was 1811, now it is 1813, and the size was previously 46 bytes, now it's 54 bytes. The same activity we will do on the version bucket. So I'll click on upload, select the file which we are trying to upload. Once the file is selected, we'll click on upload button. Once the file is successfully uploaded, you'll see the timestamp has changed from 1112 to 1114, and the size of the file has changed from 46 byte to 54 byte. Now you go back to the unversion bucket and you click on the file and see the versions. You'll not see any versions over here because the versioning is disabled on this particular bucket. But if you go back to your version bucket, click on file and open the versions, you will see there is a previous version of the file which is of the size 46 byte, which was uploaded at 1812, and you can see a current version of the file also, which is uploaded at 1814, and the size is 54 bytes. So this is how the versioning on the S3 bucket is going to help you, where you can retrieve any version of the file or object what you have uploaded into your S3 bucket, and this is going to help you in retrieving accidental deletions of the files. Uh, so this is how we do the versioning on S3 bucket.
Welcome to new video. In this video, we will be learning what is AWS KMS. So as you can see the slide, it is used for simplifying encryption. First of all, KMS is a key management service. Let's quickly understand first of all, why do we need AWS KMS? For that, I will take you to a AWS documentation about KMS. Here, let us see one thing. So, every time you interact with anything on the cloud or anything over the internet, you will be moving the data from one position or one point to the other point. It will be moving across the internet between different geographies, different regions, between different machines. So whenever data is moving or whenever data is at rest, there are only two states for a data, that is, it can either be in transit or it can be at rest. So how do we traditionally used to handle that is, let's say the purple color box here is shown as data. For example, if there is no any kind of encryption, anyone like hacker, someone who want to tamper with your data can always have access to your data, and hackers will never do good things with the data, so they'll try to misuse the data. So in order to avoid this scenario, what we do is there is something called as a data key. You will encrypt the data and using a data key, and you will move the data that is encrypted across the machines or across the internet. Now the challenge is, what if your data key itself is uh, compromised? Still, someone who want to access your data can use that key and access your data. To handle that, what is done is, again you encrypt the key, you create a root key as you can see in the screen. So again you have a key for a key. For someone to tackle like someone to tamper the data, he needs a root key. Using the root key he can get the data key, from the data key he can get the data. But still here there is a bit of compromise. What if someone accesses the root key? Again your data can be compromised. So there is no end for this. Like you can have how many ever layers you want, but still your key, if it is accessible to anyone, your data is compromised. In order to address this particular problem, AWS has come up with a service called KMS. What KMS does is, similar to the original structure we have just seen, there is a data key which encrypts the actual data, and there is a root key. The root key here is called as KMS key. But how is this more safer than the original approach is, the key will never go out of the KMS service. So whatever servers or whatever point where this KMS is storing the root keys, there is no way that these keys are going out of it. The only way how these keys goes out of it is through an API call, and that too in an encrypted format. So that's why KMS keys are so secure. They protect your root keys, and that's why KMS came into the existence. Let's go back to the presentation to learn what are the different points in KMS. Later on, we will see how it actually looks in the console. As we discussed till now, what is AWS KMS? It's the managed service simplifying creation, control, and management of encryption keys used to secure data. So as we are discussing till now, KMS is a service which helps us in controlling, creating, and managing the encryption keys. Guys, don't get confused when I say encryption. They are also decryption keys as well. The same key can be used for encryption and decryption as well. And integration with AWS. This KMS can seamlessly integrate with other AWS services like S3 or DynamoDB or RDS or anything where you store the data, or any application as well. And it also, like as I mentioned, it doesn't go out of any AWS KMS facility. That means it follows certain guidelines and rules which ensures the data security and compliance. Let me show that in the page. Like if you see on the top, KMS keys are protected by FIPS 142 validated HSMs. HSMs are hardware security modules. They have certain guidelines to be followed, and they are the devices that cannot be tampered. If someone tries to tamper the HSM, the complete data present in HSM will be lost. So that's how KMS keys are so secure. Okay, now looking at the core features of KMS. KMS have these core features like key management, key policies, encryption and decryption, AWS integration, customer master keys, and auditing. So we know key management, like we have discussed that till now. You can create, import, rotate, and delete the cryptographic keys or the encryption keys. Rotate here in the sense, for example, you are having a password and that is set for certain number of days. For example, if it is there for more number of days, there is a high chance that people who are using it might compromise it. So what KMS does in the background is, after every set of days that you fix, the keys will be changed. That is, they will be rotated. Then comes key policies. Similar to IAM roles, you can have a key policy which will govern the way key can be used. You can set up some restrictions on that, who can access the key, who cannot access the key, and what services can access the key and what services cannot access the key. So you can either use IAM policies or resource based policies. As I said, you can control on a resource level or on the user level. Now encryption and decryption, that's a basic feature of KMS keys. And AWS integration, like these are all the AWS services that can seamlessly integrate with KMS. And in KMS there are two types of keys you need to know. One is AWS managed keys and two is customer managed keys. AWS managed keys are the keys that we don't have control on. We don't create it, we don't manage it. AWS creates it and AWS manages it. So there is a table that I have that I want to show where there is a clear differentiation of what each of these keys does. And auditing. Now let's say you are handling a bigger project where you are having a lot of keys to involve. Now you don't know which key is accessed when and how many times it is accessed. So it's completely integrated with a service called AWS CloudTrail, where you can track and audit each and every individual key, how many calls has been done, how many of them are successful and how many of them are failure, how many of them are coming from unauthorized point, anything like that. Moving ahead, now functionality: key creation, data encryption, decryption, and key storage. So these are the different functionalities that are present with KMS. You can create a key, and using that key you can encrypt the data, you can decrypt the data, and there is something called key storage. Why I have mentioned key storage here is this incurs certain cost. So there are two keys as we spoke about: AWS managed key and customer managed key. So for customer managed key, since you will create the key, that needs to be stored in a certain point, like a HSM, like hardware devices. So to store it there, it needs certain cost. So that needs to be paid by the customer. We will be looking at the cost details when we come to that point in the video. So this is about AWS KMS's functionality and types of keys. As I mentioned, there are only two keys, but here you can see three keys. That is AWS managed key, customer managed keys, and data keys. Why data keys are specially mentioned here is, in custom managed keys, there is only a limitation of 4 KB of data that you can encrypt with that. But if you want to encrypt a larger files, like larger data, customer managed keys cannot be used. In those scenarios, what you do is you generate a data key using a customer managed key, and that data key can encrypt the large data sets or large amount of information like a text or anything for that matter. So typically there are two types of keys, but explicitly when someone asks, there are three different keys there: AWS managed key, customer managed key, and data keys. Now we have come to price overview. Before I go to price overview, let me take you to the documentation. So yeah, so there is a table that clearly mentions here things that's between customer managed key, AWS managed key, and there is something called AWS owned key. The reason why we are not discussing AWS owned keys is they are completely owned by AWS. We cannot see them, we cannot access them, and there is no charge associated with that. That is, AWS in the background, in order to encrypt any default data, they uses AWS owned keys. If you remember, when you create an S3 bucket, there is something called default encryption. To do these default encryptions and all, AWS uses AWS owned keys. Now let us explore two things: customer managed key and AWS managed key. In customer managed key, key policy exclusively controlled by the customer. In AWS managed, controlled by the service. And coming to price point, since in AWS managed key it is not created by the customer, there is no monthly fee. That is, there is no fee that you need to pay for storage of the key. However, you need to pay for the API calls, like how many times the key has been accessed, because AWS creates those keys only on your request. Like if you are creating some kind of a service or some kind of a data pipeline where you need some encryption in the middle, and you opted that AWS managed like keys, there these keys are created, and in those scenarios there will be no monthly cost, but API calls will be definitely charged. In customer managed keys, there will be two kinds of charges. One is monthly fee and also the fee that incurs for the API calls. And logging, when it comes to logging, CloudTrail has a logging for both the keys like customer managed and AWS managed. In lifecycle management, AWS KMS manages rotation, deletion, and regional location annual. That is by default, it is annually, but in customer managed, you can set up the timing like you want to rotate it every 90 days or every 100 days or according to your whatever time is comfortable for you. This is about customer managed and AWS managed and pricing of different keys. So the two costs involved here is the storage cost and the key usage cost. Key usage cost here refers the charge for API request to manage and use keys. For example, you created a key and that key is encrypting certain data. Every time you want to access that data, you need to hit the KMS API call. So each of those call will be having certain cost or fee associated with that which you need to pay. And in free tier, it includes 20,000 free requests per month. So 20,000 free API calls can be done in the free tier for each month. So just going overview of the key concepts, KMS has key rotation, access control, and envelope encryption. You can pause the screen and just read what it's been written here. It's about encrypting the data, how we do that, and how do we do key rotation, and what are the different access controls we can implement over here. Now, real world cases. Where do we actually use AWS KMS? So to secure S3 buckets, to encrypt the databases, and to secure applications, and to meet the industry compliances. These are only few real world cases where you use KMS, but there is a wide applications where you might be needing AWS KMS in order to encrypt the data, to protect from the hackers, or to protect the data from unauthorized access and something like that. Let's quickly go to the console and check how KMS looks like. When you land into your AWS console, you will be landing into some kind of page like this. Go to the search bar and type KMS. You will be landing into key management service. If you click on that, you will be, AWS will take you to the KMS landing page. Let's wait for the page to load. Here you can see two keys, AWS managed keys and customer managed keys. And if I go ahead and click on AWS managed keys, here it will show the keys that are created by the AWS whenever you are trying to do some kind of a data pipeline where you opted for AWS to manage things. Like for example, you have opted some serverless application. In serverless application, in order to encrypt the data, you will not create any KMS key. AWS will create some key. And customer managed key, here you need to create each and every individual key. You have the power to rotate the keys, delete the keys, update the keys, and modify the keys. And this is how the console looks like. You can start exploring the console on your own. Hit on create key. You will be taken to some wizard where you will be moving step by step how you want to use that keys. There are type of the key, asymmetric and symmetric key. Choose whichever you want. Let me quickly read what is symmetric and what is asymmetric for your clarity. In symmetric key is a single key used for encrypting and decrypting data or generating and verifying HMAC codes. In asymmetric key, a public and a private key pair used for encrypting and decrypting data, signing and verifying messages, or deriving shared secrets. So here there will only be a single key used for the encryption and decryption. Here there will be two keys. One is a public key, one is a private key. Public key is used in your codes in order to access the information, but in AWS KMS it stores the private key, and there is a connection inside where it maps which public key needs to be used for which private key. Using that, a data will be encrypted or decrypted. You can go through this wizard and click on and get created with your AWS KMS keys. So let's quickly come back to the conclusion. So let me put everything into a nutshell. In this video, what we have learned is Why do we need a KMS? Like in order, why are we using KMS even we have keys to encrypt and decrypt the data? And we have seen what are the basic features of KMS. You can encrypt and decrypt the data. You can apply the access control policy. You can have the resource policies and all. Then we looked at the pricing of the KMS. You need to pay for the monthly storage cost and you need to pay for the API calls if it is a customer managed. If it's AWS managed, you will only pay for the API calls. Then we looked at the actual application, where is the KMS and how does the page looks like and how to create a KMS key. And with this, we have come to end of this video. Thank you and happy learning.
Hello everyone. So in this video, we are going to see what is AWS Key Management Service, which we call as AWS KMS. So AWS KMS is a managed service provided by Amazon Web Service that allows companies to create, control, and manage the cryptographic keys that is going to help in encrypting and protecting their data. With AWS KMS, organization get a world-class key storage, management, and auditing system that makes it easy to control the encryption of data stored across different AWS services. Uh, Organization can use the encryption keys and functionalities provided by AWS KMS to protect the data in all their application that uses AWS. So if you see here, so you have a data and that data will be encrypted with a data key. But on top of that, what we do, we use AWS KMS, which is going to encrypt the data key also, which is called, we call as a master key. So until unless you have that master key, you will not be able to decrypt the data while accessing that data from any of the application or services in AWS. Now let's see what is a key in AWS KMS. So AWS KMS key is a logical representation of a cryptographic key. It is a primary resource in AWS KMS key. Uh, there are three types of KMS key that can be created in AWS KMS. The first is customer managed key. So any key which is being created or maintained by an organization, that is we call as customer managed key. The second is AWS managed key. So any key which is created by AWS services that uses the KMS key to encrypt the organizational service resources, that we call as AWS managed key. The third is the AWS own key. So the KMS keys created by AWS services in a service account is called as AWS own key. Now a KMS key contains two information. The first is the metadata. That metadata contains a key ID, key specs, the key usage, creation date, description, and key state. And the second component is we call as reference, that is to the key material used when the cryptographic operations are performed within the KMS key. So these are the two components currently available as part of your KMS key. Now let's see some of the features of AWS KMS. The first is it is it's a very easy way to control and access your data using managed encryption. Okay. Uh, the process of key management is reduced to a simple few clicks with the help of AWS Key Management Service. It also easily integrates with other AWS services, including Amazon EBS, Amazon S3, Redshift, to simplify the encryption of your data within these services. It also enables you to create, rotate, disable, enable, or define usage policies for master keys and audit their usage. Uh, it is a centralized key management service provided by AWS, and it is also very secure and compliant. So these are the few of the services of AWS KMS. Now let's see some of the advantages of AWS KMS. So the first is it's fully managed. It's all controlled by the user because you access the encrypted data by assigning permissions to use the key, while AWS Key Management Service deals with long-lasting and physical security of your keys, hence enforcing your permissions. It's a centralized key management service. Uh, it provides a single point and defines policies continuously across AWS services and also your own applications. It helps in encrypt data in your application. So by using a simple API, you can build encryption and key management in your own application by using AWS KMS. It's a very low cost service, as there are no charges to use AWS Key Management Service. You are only charged when you use or manage the key beyond the free tier. It's a very secure. So the AWS KMS use hardware security module that has been validated under FIPS 140-2, which is like Federal Information Processing Standard publication. So it's a very secured service of AWS. The last is it's a very compliant. So the security and the quality control in AWS KMS has been certified under multiple compliance schemes. So these are few of the advantages of using AWS KMS key. Thank you. Hello everyone. So in this video, we are going to see how do we create in AWS KMS. So to create a key, first log into your AWS management console. Once you log in it, just simply search for KMS in the search bar and you should be able to see key management service. Just click it to open it. Once you are in the KMS dashboard, you should be see two options. One is AWS managed key and another one is customer managed key. So AWS managed keys are the keys which is by default created by AWS, and these keys could be used to encrypt or decrypt the data with the respective services. So if you see, you could be able to see different AWS managed key already created in your account, such as AWS 3, AWS Lambda, Secrets Manager, Redshift, SNS. So if you want to encrypt or decrypt the data inside any of these services, you can take use of these AWS managed key and then encrypt and decrypt the data accordingly. Now let's see, you want to create any key based on your requirement. You have to come back to the customer managed key sections where you can create your own KMS key. So just simply click on customer managed key and you should be able to see all the others key which is already being created by yourself over here in the customer managed key. If you want to create a new key, just simply click on create key. Uh, in the configure key page, you should be able to see first a key type. So currently there are two types of key which is available in KMS. First is symmetric key and another is asymmetric key. So symmetric key is nothing but over here you could use only a single key to encrypt and decrypt the data. But in the asymmetric key, it works on a public and private key pair combination. So you need to create a private key. Also, you need to create a public key, and you need to share the public key with whoever is trying to access the data. And when you send the data, they will use the public key to decrypt the data on their end. So this is the asymmetric. So we'll keep the key type as symmetric. The key usages, currently you can use these keys to encrypt and decrypt the data, or you can generate and verify MAC. So we will use this key to only encrypt and decrypt the data. So let's choose that option. In the advanced option, you will see the key material origin. So this is nothing but a key property that represent the source of the key material when creating the KMS key. So there are four different options what we have, but we'll choose the default one, which is the recommended by the KMS. Now in the regionality, you will have two options. One is single region key and one will have multi-region key. So single region key is only going to work into one single. Uh, this keys never allow you to replicate in another regions. But in terms of the multi-region key, you can use this key to replicate in other regions also. So let's choose single region key and click on next. Now here, you need to provide an alias to this particular key. So this is going to help you identify, since you will create multiple KMS key and you want to identify which key is being used where for which service. So you need to provide an alias. So let's give an alias that, okay, this is a KMS key which I am creating for my S3 bucket to encrypt and decrypt the data. So let's give a suitable name like Academy S3. So this is the name of my, this is the alias for my key. Now you can provide a description such that used to encrypt and decrypt the data in my S3 bucket. Okay. The tag, it's optional. If you want to add any tag, you can just click on add tag and attach any tag to this particular key. Now, once you fill all this information, click on next. Now here it will ask you the key administrator who is going to create or modify or delete this particular key. So you could have different IAM users which is already created. So whichever is the administrator user for your account, just select that. So if you see here, I've logged into this particular with this particular user. So I'm going to select this user only who has the access to monitor or access or delete this particular KMS key. Once you select the user, you can select one user or you can select more than one user also. Click on next. Here it is going to ask you the key users who is going to use this KMS key. So if you select those users and IAM roles, they will only have the access to access this use this KMS key while encrypting and decrypting the data. So let's select the same user here also. Okay, and click on next. Now in the review section, you review everything what you have given. So in the key configuration, you have selected the type as symmetry. You have the regionality as single region key. The key usage is encrypt and decrypt. This is the alias what you have given to identify your keys from the list of all the keys. You have not given any tags, and this is the policy where it says that okay, this is the administrator, this is the user who is going to perform all these actions on your KMS, and this is the same user who is going to perform these different actions on your KMS key. So once you verify everything, you just click on finish to create your KMS key. So once you everything is successfully, you should be able to see your customer managed key, which is this key what you have created now. And this key can be used now going forward to encrypt and decrypt any data into your S3 bucket. So this is how you create a customer managed key in your AWS KMS. Thank you. Hello everyone. So in this video, we are going to talk about what is AWS Secrets Manager. It is a service provided by AWS to store secrets, that is passwords, credentials, third-party key, or any such confidential information which you are using as part of your application. Secrets Manager allow you to store and manage access to those credentials. It also help you replace hard-coded credentials in your code. With a simple API call to your Secrets Manager, you should be able to easily retrieve those credentials and replace them in your program programmatically. It also encrypt the protected text of the secrets using AWS Key Managed Services. Now let's see what are certain features of a secrets manager. So the first one is it rotates secrets safely. So without worrying about updating or deploying the code, you can easily change your secrets manager in order to ensure that your security and compliance requirements are met. The second is it secures and audits secrets centrally. So by encrypting the secrets with encryption key, you can secure your secrets in your application. The third one is you pay as you go. So secrets manager is a pay as you go model. So you will only be charged for the number of secrets you manage uh, by the secrets manager and the number of secrets manager API calls made. The last one is it retrieve secrets programmatically. So with secrets manager, you can programmatically retrieve encrypted secrets value at the runtime in your application. So these are the certain features of secrets manager. Now let's see how do we use secrets manager. So if you see this diagram, so we have Alice. C is the database administrator for one of the SQL server. And we also have Bob, who is running an application which is accessing the data from this SQL server. Now, let's take a scenario where Alice has updated the current password of the SQL Server database. And what she does, she also store the newly created password into the AWS Secrets Manager. Now, whenever Bob is running his application to access the data from the SQL Server, his application is retrieving the credential of the SQL Server from the Secrets Manager. So in this scenario, when Alice updated the password of the SQL Server, Bob does not have to do anything or any changes on his application. The application automatically retrieves the newly created password from the Secrets Manager, and then it uses that password to connect to the SQL server and then access the data. Hello everyone. So in this video, we are going to see how do we create in AWS KMS. So to create a key, first log into your AWS management console. Once you log in it, just simply search for KMS in the search bar and you should be able to see key management service. Just click it to open it. Once you are in the KMS dashboard, you should be see two options. One is AWS managed key and another one is customer managed key. So AWS managed keys are the keys which is by default created by AWS, and these keys could be used to encrypt or decrypt the data with the respective services. So if you see, you could be able to see different AWS managed key already created in your account, such as AWS 3, AWS Lambda, Secrets Manager, Redshift, SNS. So if you want to encrypt or decrypt the data inside any of these services, you can take use of these AWS managed key and then encrypt and decrypt the data accordingly. Now let's see, you want to create any key based on your requirement. You have to come back to the customer managed key sections where you can create your own KMS key. So just simply click on customer managed key and you should be able to see all the others key which is already being created by yourself over here in the customer managed key. If you want to create a new key, just simply click on create key. Uh, in the configure key page, you should be able to see first a key type. So currently there are two types of key which is available in KMS. First is symmetric key and another is asymmetric key. So symmetric key is nothing but over here you could use only a single key to encrypt and decrypt the data. But in the asymmetric key, it works on a public and private key pair combination. So you need to create a private key. Also, you need to create a public key, and you need to share the public key with whoever is trying to access the data. And when you send the data, they will use the public key to decrypt the data on their end. So this is the asymmetric. So we'll keep the key type as symmetric. The key usages, currently you can use these keys to encrypt and decrypt the data, or you can generate and verify MAC. So we will use this key to only encrypt and decrypt the data. So let's choose that option. In the advanced option, you will see the key material origin. So this is nothing but a key property that represent the source of the key material when creating the KMS key. So there are four different options what we have, but we'll choose the default one, which is the recommended by the KMS. Now in the regionality, you will have two options. One is single region key and one will have multi-region key. So single region key is only going to work into one single. Uh, this keys never allow you to replicate in another regions, but in terms of the multi-region key, you can use this key to replicate in other regions also. So let's choose single region key and click on next. Now here, you need to provide an alias to this particular key. So this is going to help you identify, since you will create multiple KMS key and you want to identify which key is being used where for which service. So you need to provide an alias. So let's give an alias that, okay, this is a KMS key which I am creating for my S3 bucket to encrypt and decrypt the data. So let's give a suitable name like Academy S3. So this is the name of my, this is the alias for my key. Now you can provide a description such that used to encrypt and decrypt the data in my S3 bucket. Okay. The tag, it's optional. If you want to add any tag, you can just click on add tag and attach any tag to this particular key. Now, once you fill all this information, click on next. Now here it will ask you the key administrator who is going to uh, create or modify or delete this particular key. So you could have different IAM users which is already created. So whichever is the administrator user for your account, just select that. So if you see here, I've logged into this particular with this particular user. So I'm going to select this user only who has the access to monitor or access or delete this particular KMS key. Once you select the user, you can select one user or you can select more than one user also. Click on next. Here it is going to ask you the key users who is going to use this KMS key. So if you select those users and IAM roles, they will only have the access to access this use this KMS key while encrypting and decrypting the data. So let's select the same user here also. Okay, and click on next. Now in the review section, you review everything what you have given. So in the key configuration, you have selected the type as symmetry. You have the regionality as single region key. The key usage is encrypt and decrypt. This is the alias what you have given to identify your keys from the list of all the keys. You have not given any tags, and this is the policy where it says that okay, this is the administrator, this is the user who is going to perform all these actions on your KMS, and this is the same user who is going to perform these different actions on your KMS key. So once you verify everything, you just click on finish to create your KMS key. So once you everything is successfully, you should be able to see your customer managed key, which is this key what you have created now. And this key can be used now going forward to encrypt and decrypt any data into your S3 bucket. So this is how you create a customer managed key in your AWS KMS. Thank you. Hello everyone. In this topic, we are going to talk about what is AWS SNS. SNS stands for Simple Notification Service. It is one of the important service provided by AWS Cloud. It is a web service which makes it easy to set up, operate, and send notification from the cloud. It also provides developer with the highly scalable, cost-effective, and flexible capability to publish messages from an application and send them to another application. So in a nutshell, it is a way of sending messages. Let's take an example. When you're using an auto scaling in your AWS cloud, it triggers an SNS service which will email you saying that your EC2 instance is growing. So now let's see how SNS works. SNS works in a publisher and subscriber model. So you will have a publishers and then you will have subscriber. Publishers, which are also known as producer, that produces and sends the messages to the SNS topic, which is going to be the logical access point for all the subscriber. Uh, in terms of subscribers such as web services, email addresses, Amazon SQS queues, or AWS Lambda functions, which receive those messages and notification, they are known as the subscribers. Now let's see some of the benefits of using an SNS. So there are multiple benefits, but few of them which is very important are listed here. So first is instantaneous delivery of the messages. So because SNS works on a push delivery based mechanism, it pushes all the messages in a topic, and the messages are delivered to the multiple subscriber instantaneously. It is also very flexible to be used because it supports multiple endpoints such as email, SMS, Lambda, Amazon SQS, and HTTP. So it's very flexible in its use. Also, it's very inexpensive because it is based on a pay-as-you-go model. So you need to pay when you are using the resources without any upfront cost. Ease of use, SNS service is very simple to use. You just need to create a topic uh, and multiple subscriber can subscribe to that topic, and then when the publishers pushes the messages, it automatically delivers to those subscribers. It has a very simple architecture. So instead of receiving all the messages from the topic, SNS sends the messages to the subscriber only of their interest. Hello everyone. In this video, we are going to see how do we create a topic in SNS, and then how can we publish a message from a publisher to the same topic, and then we'll send the message from the same topic to a subscriber. So to create a topic, if you already have a AWS account, log into your AWS management console and simply type SNS into your search bar. You should be able to see simple notification service. Just click it to open it. Once you open it, you will see this particular page where it will ask you to create a topic. So let's give a name to your topic. So I will give this name and then we'll click next step. Now it will ask you to configure this particular topic. So the first is what is the type of topic you want to create. So there are currently two types of topics what you create. One is first in, first out, where it maintains the ordering of the messages which is going to come to the topic from any of the publishers. The second is standard. It by large it maintains the order of the messages which being published to your topics, but up to a certain extent. So let's keep that as a default. The name of the topic we have already given on the first page. Now we'll keep everything as default, and then what we will do, we'll click on create topic. Once the process is successful, you should be able to see your topics created successfully. Now if you want to see your topics, click on the topics and you should be able to see your topic successfully created. So this is how you can create a topic into SNS, very simple process. Now let's see how do we publish a message out of this particular topic to a subscriber. So for that, just simply click your topic. So as we discussed earlier that SNS Topics works on a publisher and subscriber mechanism. So to get a message, you need to subscribe this particular topic. So let's create a subscription first. So you come back to your subscription tab and click on create subscription here. Now this is the ARN of this particular topic, and the next it will ask what is the endpoint you want to subscribe. So if you click on this drop down, you'll see different options here. So you can create a subscription to your Kinesis data stream. You could do a subscription on SQS, Lambda, email, HTTP, and SMS also. So these are the different endpoints which can subscribe to this particular topic. So at this point of time, let's create an endpoint to email subscription. So once you select email, it will ask you the endpoint. So in this endpoint, you have to give the email ID at which you want to create this subscription. So let's give any email ID what you have. Simply copy it and paste your email ID over here. And after that, you'll keep everything as default and you'll click on create subscription. So once your subscription is created successfully, you go back to your topic and you'll see that any subscription what you create in SNS, you need to first confirm that subscription. Then only you should be able to send a message to that particular endpoint. So if you see the current status of this subscription is pending confirmation. So for that, you go back to your email ID, what you have provided into your endpoint and confirm the subscription. So if I go back to the email ID which I have given, I could see there is a message from AWS notification where it is requesting me to confirm the subscription. So I'll just click on confirm subscription. And once the subscription is confirmed, you go back to your SNS and simply refresh your page. You should be able to see your subscription is now in the confirmed status. Now, once the subscription is confirmed, uh, it is ready to send a messages from this particular SNS topic to the endpoint which has been subscribed to this particular topic. So to send a message, simply click on publish message on the top, click on this one, and it will ask you to provide your subject line. So let's provide something test message. Then it will ask you to provide the body for that message. So let's provide some body. I So this is the body, and let's keep everything as default. and then click on publish message. So once the message is published successfully, you should be able to see this particular message into your email ID which you have provided. So go back to your email, and you could see there is a notification which came from AWS. So just click on that, and you could see the message what you have sent from AWS SNS. So this is how you can create a topic, you can create a subscription on a certain endpoints and publish a message from this particular to this particular SNS topic to that particular endpoint. So till now we are manually publishing a message to this SNS topic, and then from here we are sending the same message to the email subscriptions what we have created on this SNS topic. Now let's see how do we send a message from an actual publisher to this topic, and then from here we will send that same message to the same email subscription what we had created. So for this use case we will use S3 bucket as our publisher, where any upload happened to that particular S3 bucket should send a message from the S3 bucket to this topic saying that there is a new file which has been uploaded, and we will get that message to the email subscription endpoint what we have created. Since S3 bucket is going to be the publisher for this SNS topic, we have to give the access to the S3 bucket so that it should be able to publish a message to this topic. So for that, you need to update the access policy of this SNS topic. So for that, you simply click on edit. So once you are in the edit topic page, you will come to the access policy. So there is already a default policy which is given. Now you want to tweak this policy for your S3 bucket. So for that, simply click on this info button, and this will give you an example of all the different policies what you create based on your different publisher. So simply click on this example page. You could see different options what you have, but we are interested in sending the message from an Amazon S3 event notification. So simply click on this particular page and you will able to see a default JSON which is given, where you just need to tweak this JSON based on your resources, where you provide your own topic ARN and your own source account. So simply click this particular JSON, come back to your topic and copy the same, delete the existing policy and copy the ones which you have copied from the other page. Now you need to update your resource. Here you will provide your topic ARN. So for that you simply open your topic again, and you could see the ARN provided here on the topic page. So simply copy your ARN from here, come back to your uh, edit page of your topic and paste the one the paste the ARN which you have copied. Now you need to provide your AWS account ID. So you could get your account ID from top right corner. You simply click over here and you should able to see your account ID here. So simply copy this one, click on this box, your account ID is copied, and come back here and paste that. So now uh, the access policy of this particular topic is successfully updated, where you are saying that any actions which are coming from the S3 bucket, uh, you are allowing that to publish that message to this particular topic. Okay, so this is the policy what we have to give to this SNS topic, so that S3 should be able to write the message to this SNS topic. So once you update this policy, simply come back and click on Save Changes. Now your topic access policy is successfully uploaded. Now, now we have to go back to our S3 bucket and create an event notification so that any upload happen to that S3 bucket should send a message or notification to this SNS topic. So for that, simply go back to your AWS console, search for S3 and click it to open it. So once you are on the Amazon S3 bucket page, let's create a bucket uh, in which we are going to set up the event notification process, which is going to send a message or notification to your respective SNS topic whenever you upload a file. So to create a bucket, simply click on create bucket button, and let's give a name to your bucket. This name needs to be unique. So simply select any name which you want and give a name to that particular bucket. Let's keep everything as default and simply click the create bucket button. So once your bucket is created successfully, let's open this bucket. Go to your go to the properties section of this bucket, and if you scroll down, you should be able to see a section called event notification. So let's create an event notification by simply clicking on create event notification. You can give this event a name. So simply give a name like SNS topic event. Keep the prefix and suffix as default. We don't have to give it because we want to create this notification on the entire bucket, so that anything uploaded to the bucket should send a notification to your SNS topic. But if you want to create this event on a certain specific folder inside your bucket, then you could give a prefix of that folder from which you want to create this event. As of now, we will keep this as default. Let's come back to the event type. So the idea for this particular process is that it should send a notification to your SNS topic whenever you upload a file or create a file into your S3 bucket. So simply click the object creation option where we'll select all the object creation, whether you put a object, you post a object, or you upload a object, it should be able to send a notification to your SNS topic. Will not select anything else. Keep scrolling down. So you'll see a destination section where you will have three options: Lambda, SNS, and SQS. At this point of time, we are only focusing on SNS topic. So let's select the SNS topic option. And then once you select that, it will ask you to provide that SNS topic. So either you can choose the SNS topic or provide the ARN of that particular topic. So let's select the choose your SNS topic, and you can click on this drop down and you should be able to see the SNS topic which you have already created. So this is the SNS topic where we want to send the notification. So simply select this topic. Now click on save the changes. So once the process runs successfully, you should be able to see a event notification created on this particular S3 bucket. Now let's see what happens if you upload a file into your S3 bucket. Will that send a notification to SNS topic, and will you get a message into your email subscriptions what you have created on your SNS topic? So to upload a file, simply click on upload. Add the file which you want to upload here. So let's select that file which you want to upload. So this is the CSV file which I am uploading into this S3 bucket, and hopefully it should send a notification to SNS, and you will get an email into your email ID saying that there is a upload happened to your S3 bucket. So click on upload. Now your file is successfully uploaded to your S3 bucket. Now let's go back to our email ID which we have created as a configuration into our SNS topic and see if you have received any notification. You can see there is a notification from AWS. So just open this notification and you will see this is the message what you have received from the SNS topic, where you could see that this is the event name, where it shows that there is an object which is created into this particular bucket where you have created the event notification, and this is the object what you have. This is the data.csv which you have uploaded into S3 bucket. So this is how the SNS is going to help you send the messages to any endpoints what you have created as part of the subscription from any publishers. In this case, we have the S3 bucket as the publisher. Thank you. Hello everyone. So in this video, we are going to talk about what is AWS SQS. So SQS stands for Simple Queue Service. It is a web service that gives you an access to a message queue that can be used to store messages while waiting for a computer and application to process them. With the help of SQS, you can send, store, and retrieve messages between different software components without losing those messages. The messages can contain up to 256 KB, and they can be of any format such as JSON or XMLs. Any component which wants to retrieve those messages out of SQS, they can use the Amazon SQS API to retrieve them. Now let's see what all different types of queues we have in SQS. So there are two types of queues we have. The first is the standard queue, which is the default, and the second one is the FIFO queues, which is first in, first out. Now let's see what is the standard queue. Standard queue in SQS is the default queue what AWS provides. It allows you to have unlimited number of transactions per second. It guarantees that a message is delivered at once, but sometimes more than one copy of message might be delivered out of an order. It also provides a best effort in ordering, which ensures that messages are generally delivered in the same order what they have sent to, but it does not provide a guarantee. Now let's see what is a FIFO queue. So FIFO queue is nothing but it complements what the standard queue we have. It guarantees the ordering. So the order in which the messages are sent, it is received in the same order into the queue. The most important feature of FIFO queue is that a message is delivered once and it remains available until the customer process or deletes it. And the last is that FIFO queue does not allows duplicate to be introduced in the queue. So these are some of the features of the FIFO queue. Now let's see what are the important points to remember as uh, for the SQS. So SQS is a pull based application. It's not a push based, right? So you have to go any application or customer needs to go into SQS and pull the message out of the SQS. The messages are of 256 KBs in size. They can kept in the queue from 1 minute to 14 days. This is the maximum day at which the messages will be kept in the queue. The default retention period is 4 days. So whenever you create SQS, the default retention of the messages is going to be the 4 days, which you can increase to up to 14 days. It also guarantees that your message will be processed at least once. So these are the some of the important points which you have to remember as part of the Amazon SQS. Thank you. Hello everyone. So in this video, we are going to see how do we create and use SQS in AWS. So this is the data pipeline where we have S3 bucket and AWS Lambda. And what we are doing is we are using this AWS Lambda to access a file from an S3 bucket and do some activity on that particular file. To do this activity, what we are doing, we are creating an AWS SQS, which is going to send a message to our AWS Lambda and trigger it automatically as soon as we upload or create a new file into an S3 bucket. So once the Lambda gets a message from an SQS, it automatically triggers the Lambda, and the Lambda goes to our S3 bucket and fetch the data from that S3 bucket. So to create an SQS in AWS, simply log into your AWS Management Console and in the search bar, type for SQS and you should be able to see simple queue service. Click it to open it. Once you are in SQS page, you should be able to see a create queue options. To create a new SQS queue, click on create queue. The first it will ask to select the type of the queue which you want to create. So as discussed earlier, there are two types of queues which is currently available in SQS. The first is standard and the second is FIFO. The only difference is the standard queue does not uh, preserve the ordering of the messages, but the FIFO queue, which is first in first out, it preserves the message order. So for this video, we'll select the standard queue. Then we need to provide the name of the queue. So let's provide a name of this queue. So this is the name which I'm going to provide, the academy underscore S3 SQS. After providing the name, you will have the configuration section where you will have some default values which is already available. The first is the visibility timeout, which is by default as 30 seconds. The second is the message retention period. So this is the value which is going to help you store the message for that particular time period what you have mentioned here. So by default it is going to be the 4 days, but you can go minimum as of 1 minute and maximum of 14 days. So based on your business use case, you can change this one. The other options are delivery day delay and the maximum message size. The maximum message size in SQS will always be 256. So these are the configuration which you can update based on your requirement. But as of now, we'll keep everything as default. The next is encryption. So whether you want to provide an encryption on your message, which is going out of the SQS. So once you enable, it will ask you to select the types of encryption which you want to apply. So as of now, we'll keep that as a default, which is will change it to disabled. Now, when you create an SQS, it creates an access policy, which is the default one where uh, any user into this account should be able to access or perform all the actions on this SQS queue. So we'll keep this as a default. Then the next options are redrive allow policy and which will keep as a disabled. The next is dead letter queue. So dead letter queues are nothing but let's see if there is a message which is coming in SQS and due to some issues on your application side, that message is not able to delivered or consume out of SQS queue. After some time, the SQS will move those messages to another queue, which is nothing but the dead letter queues. So you need to create a separate set of queue, which is going to hold all the undelivered messages from your actual queues. And whenever you want to reprocess those messages after fixing the issue, you can just move those queues from your dead letter queue to actual queue to process it. So for this video, we'll keep this as a disabled one. The next is tags. So this is also an optional, so we'll just keep that as a default. And to create the queue, we'll simply click on create queue. So once your queue is successfully created, you should be able to see all the options. So this is the name of the queue, this is the ARN of the queue, the encryption is default, this is the URL of the queue. Now, as part of our pipeline, what we are trying to do is send an event message from our SQS to Lambda. So let's set up this particular link from your Lambda to AWS, from your SQS to AWS Lambda. So for this video, we already have a Lambda created. So let's open our Lambda. So once you are in the Lambda, I'll open, this is the Lambda function, which is already present and I've created it, where what we are trying to do in this Lambda is we are reading the event which is coming for our SQS queue, and based on that event what is coming from SQS, we are trying to find out the bucket name, the file name, and the size of the file. And based on these details, what we are doing is in this Lambda, we are going back to our S3 bucket, reading that file, reading the data of that file and then creating a data frame out of it. So this is the flow what we are trying to do here. So now the first is to create a trigger from our SQS to Lambda. So in you come back to our your SQS, and in that you should be able to see a Lambda trigger option here. So just click on that, and this will give you an option to configure a Lambda function trigger. So click on that. Once you are in the Lambda function page, it will ask you to provide the Lambda where you want to create a trigger of SQS. So simply select that Lambda function, which is S3 read Lambda what we have. So once we select that, we click on save. So there is an error coming saying that the role which we are using as part of the Lambda does not have all the permissions to receive the messages on from an SQS. So this is an issue with the policy or the accesses which is given to the role which is being used in the Lambda function. So now let's go back to the Lambda function, and in the configuration section, you will have a permission tab. So click on that and you should be able to see the role which is being used into this Lambda function. So click on this role and you should be able to come up to your in your IAM dashboard where this is the role which is being currently used into your Lambda function. Now we have to provide SQS access to this role. So to provide that permission, you click on add permission and click on attach policy. So once you click on attach policy, it will list down all the policies which is currently available into your IAM. So simply search for SQS and you should be able to see all the AWS managed policies over here. So we currently have one. So one is SQS full access, one is SQS read only access, and another is Lambda SQS queue execution role. So as of now, let's provide full access of SQS to this particular role. So select that policy and click on add permission. Now you should be able to see that policy attached to your role. Now go back to your SQS, and where you are getting the error previously, now again try to create click on save. Now you should be able to create the trigger into your Lambda function because you have given the right permission to your role which is being used into your Lambda function. So it will take 1 minute to create this trigger. So simply refresh this trigger and you should be able to see a status as enabled. Now you go back to your Lambda function. Here you don't see any triggers as of now. Just click refresh this page and you should be able to see the SQS trigger is automatically created over here. Now this particular piece of process is now set up where you have created a trigger from your SQS to Lambda. So now any messages which is going to come to your SQS, it will automatically trigger your Lambda. Now to get that message, we have to create an event notification on our S3 bucket, which is going to send an event notification as soon we upload some data into our S3 bucket. So let's go back and search for S3 in your tab in your search bar and open your S3 buckets. Select the bucket where you want to create the event notification. So this is the bucket where I want to create. Once you are in the bucket, you click on properties and scroll down and go to the event notification section. So click on create event notification. This event notification is going to help you send a automatic message to your SQS whenever you upload or put or post any new files or new objects into your S3 bucket. So let's give a name to this event. So this will be an SQS event. Now this prefix and suffix are optional. So let's keep this one as an optional only. And in the event type, we want to create an event as soon as any new objects create into your S3 bucket. So select all here, and this is going to constitute any put operation you are doing on S3 bucket, any post operation you are doing on S3 bucket, any copy operation or any upload option you are doing. So by any means, if you are creating any new object onto your S3 bucket, this event will create it and send to an SQS. Now let's keep everything as default and scroll down. You will have a destination section where Currently we have three destination, one is Lambda, another is SNS, and another is SQS. So in this video we are only focusing on SQS queue. So select the SQS queue and choose the queue from the queue. So click on this drop down and you should be able to see your queue, which is you have created, which is this one, D Academy S3 SQS. Now when you to create this event notification, click on save changes. Now this is, now you got an error saying that okay, your AWS is unable to validate the following destination configuration. This is because the current policies which is present into your SQS does not have a permission to get the messages out of your S3 bucket. So to get any messages out of your S3 bucket, we need to go back to our SQS and update the access policy. So let's go back to our SQS queue. Okay, so this is the queue what we have. And when you come to your access policy, there is already a default policy which is present where it is saying that any user of this particular account should have permission to do anything on your SQS. But here we are not sending a messages from a user, which is this one, the root user. What we are trying to do is we are trying to send a messages from a service, and that service is an S3 service. So we have to update this principle where in place of this root we have to provide the service name. So click on edit. Once you are in the edit page, go to the access policy section and update this particular principle to the S3 service where you want to send the notification. So just remove this and paste this one where you are mentioning that the principal is going to be the S3 service, which will have allow on this SQS to perform all the actions of SQS. So once you update this policy, just scroll down and click on save. So your access policy is now updated to receive messages from an SQS S3 service. So now let's go back to our S3 bucket and try to save the changes. And this time you should be able to successfully create the event notification. So you scroll down and you should be able to see the newly event notification what you have created, where if you upload or put or post any new object onto your S3 bucket, it should be able to send a notification to your SQS queue. So now we have created an event notification. Also, we have created an event trigger from SQS to Lambda. Now, let's try to upload a file into our S3 bucket and see how the messages are flowing from SQS to Lambda, and the Lambda automatically gets triggered. And then it reads the data from your S3 bucket and perform all the activity which you have uh, given in your Lambda code. So let's go back to our S3 bucket and click on object, go to your upload section, click on upload and add the file. So this is the file which I'm trying to upload. This is the data.csv which contains 3 record. Now click on upload. Once you upload this file successfully, let's go to our Lambda function and click on monitor, and let's go and check the log of the CloudWatch. Because if the event is successfully came to our Lambda function, this Lambda function should automatically trigger. Now this is the latest log what we have. Just click on to open it, and you should be able to see this is the event which you have received from your SQS, where what it is saying that this is the S3 bucket what you have, which is D Academy training bucket, where this is the file which is the data.csv which you have uploaded just now. So as soon as this event came to SQS, the SQS triggers the Lambda, and once the Lambda gets triggered, what it does, it is trying to fetch all these details from this particular event, like okay, this is the bucket name, this is the file which you have uploaded, and it goes back to your S3 bucket and try to read that file. So this is what Lambda is doing, where it is reading the data from this particular file and then creating a data frame successfully. So this is how you can use an SQS queue to send, receive, or store messages from one application to another. In this case, we were sending a message from our S3 bucket to our Lambda function through an SQS. So this is the use of SQS in AWS, uh, where you can configure it to receive, send, and store messages accordingly. Thank you.
Welcome to the new video. In this video, we will be learning and understanding AWS Lambda. We will be learning the key features of AWS Lambda, the working of the Lambda code, and the real life use cases where we really use AWS Lambda and perform our use cases depending on the requirement. Let's get started with the video. Key features of AWS Lambda. AWS Lambda is a serverless architecture, which means we will be only focusing on development of the application or the microservice. We are not bothered about the compute capacity, that is the servers and the networking part, which makes our microservice or the application to go real time in a quicker fashion. Auto scaling. Auto scaling is a feature of AWS Lambda which allows the compute capacity to increase or decrease depending upon the demand. Sub-second metering. Lambda costs based on 100 milliseconds of compute time. So every 100 milliseconds you will be using the compute power of AWS Lambda, you will be costing accordingly. Consistent performance. Making AWS Lambda a serverless architecture, there are no flaws in networking part or the insufficiency of the compute power, which makes the performance of Lambda consistent over the longer periods and cost effective. Since we are focusing mostly on the development of the application or the microservice, the Lambda development or the application development becomes cost effective. Working of the Lambda function. Now we have created a code which performs certain action. Now we have the code. How are we going to run this code? So if we see the image, we have a triggering mechanism which runs the code and the output of the code is stored in some destination. So there is an event which will trigger our Lambda function, that is the Lambda code. The code will be executed and the output of the code is sent to some other destination. The events which can trigger a Lambda function can be something like putting an object into an S3 bucket or SNS topic or a simple message coming from an SQS queue. Any of these, or there are many events which can be used to trigger the Lambda code and execute the code. As the application becomes bigger and bigger, we will be executing more and more Lambda functions on the same kind of architecture. So you will be importing the modules in every Lambda function. In order to avoid this, there is a concept called Lambda layers. Let us understand Lambda layers. Now, according to the picture, there are four different modules that are being used in three different Lambda functions. So if we import the four modules in all the three functions, the code becomes heavy to execute and your compute performance will be compromised. So Lambda layer is a layer wherein you import all these modules in the layer and you can use that layer on top of your Lambda function, and you can use this layer on multiple Lambda codes, which makes your Lambda codes lighter and faster to execute. And for a single Lambda function, you can use up to 5 Lambda layers, which makes your compute faster and your Lambda function performance will be enhanced over multiple times. Different Lambda function components. So destinations. Destination is other AWS services or any other service which takes the output of the Lambda function and uses as an input. Lambda trigger. Trigger is an event which is used to trigger our Lambda code. And layers. As we have discussed, Lambda layers are on top of Lambda code, which makes our compute faster and makes our code lighter. And function URL. And to check the Lambda's status every time, you no need to go to your AWS management console. You can assign a function URL which you can use it to track your Lambda function. You just paste it in your Chrome browser, anything you use, and your function status will be shown on the URL, which makes the Lambda more versatile to use across board. And test event. Before we deploy our Lambda function to real time or production, we want to test it using different events or different workloads or payloads. You can configure a test event such that resembles the real time payload, and you can execute your code in order to understand the flaws in your code, or you can debug your code using the test event. These are the different Lambda function components. Now, let us learn about different attributes other than the components. These are the few other attributes of AWS Lambda. Concurrency. For example, your Lambda function is already executing and another event have triggered your Lambda function, and second time the Lambda function has been triggered. So you can parallelly run multiple times a single Lambda function. I mean, all the runs can be happening concurrently, which makes Lambda function more versatile. And 15 minutes runtime. So the constraint of Lambda function is it can only execute the code for 15 minutes. For runtimes greater than 15 minutes, Lambda function is not compatible for that. So other than using your Lambda function by deploying your code in the form of zip files, or you can script your code in Lambda code editor, you can use an container image to develop a Lambda function. And for example, now your Lambda function is developed by multiple developers, and you have a code signing configuration, which means every time there needs to be a deployment, it has to go through a code signing configuration, which makes your Lambda more authentic and failure proof. Let's get into the Lambda code anatomy. Every Lambda code has three kinds of features in it: Lambda handler, an event, and the context. So, Lambda handler is a function inside which you will have the processes you want to execute. And event is the payload that you get from a trigger. It is in the form of a JSON basically. And context is a input which stores the execution variables, like what is the runtime you're executing, what is the compute you're using, what are the different function elements that are integrated when you create a Lambda function. So Lambda code anatomy comprises of Lambda handler, Lambda event, and the context. So once you are executing number of lambdas, you want to understand the metrics to improvise to make the performance enhanced. So Lambda offers you different kind of metrics, out of which the first one is performance metrics. How much of memory you are using, how much of compute capacity is you are using, what is the time you are using to execute a Lambda function, using which you can optimize your Lambda. And concurrency metrics, how many concurrent invocations are happening, how many times the Lambda is being invoked simultaneously is shown in the concurrency metrics. The final metrics are invocation metrics. How many invocations of your Lambda happened in a day, or how many times your Lambda function is invoked, and which invocation is causing more compute capacity, or shown in invocation metrics. So Lambda gives you performance metrics, concurrency metrics, and invocation metrics. So, what are the use cases where we can use AWS Lambda to leverage and execute the microservices or the applications? So, the first use case is data processing. Let's say a file is being come into your S3 bucket every day and you want to make it into a different format so that it can be used into some other ways. So you can set up an event to your S3 bucket such that every time a new file comes into your S3 bucket, it will act as an event to your Lambda and it is triggered, which runs the code and changes the format of the file depending upon the processing you want, and it is fed into different AWS service or into a different purpose. Instead of S3 bucket, here you can have an SNS topic as an event or an SQS queue. This comprises into data processing use case where you can process the data depending upon the event, like putting an object into an S3 bucket, receiving a message into an SQS queue or an SNS topic. So the next use case we are discussing is job scheduling. For example, you are having a requirement of running a particular code depending on the time of the event or execution time or an code CloudWatch event. You can set up CloudWatch event as a trigger to your AWS Lambda and execute your Lambda function. Like for example, every day at 9 a.m. you need to send some notification scripting some message in it, so you can set up a CloudWatch event that triggers your Lambda at every day 9 p.m. So you will be sending the message at 9 p.m. every day based on the event triggered from CloudWatch and AWS Lambda as a function. The final use case that we are discussing are serverless API backend. So you can set up many APIs in a serverless API backend microservice in which you use API gateways output as an input to your AWS Lambda, and your Lambda function writes into your Amazon DynamoDB. That's the table where you store the output of the Lambda. So API gateway can be used to trigger multiple HTTP requests. Depending on the request, you will execute the Lambda function. For example, you have set up a Lambda function for a post command. You have set up a Lambda function for a get command or a put command. So according to the request, the Lambda is processed and the output is stored in the DynamoDB. So these are the different Lambda use cases. With this, we have come to the end of the video.
Hello everyone. So in this video, we are going to see what is AWS Lambda. AWS Lambda are serverless compute functions which are fully managed by AWS, where any developers can run their code without worrying about the servers. Uh, AWS Lambda functions will allow you to run the code without provisioning or managing any server. So the backend infrastructure we don't have to worry about in case of AWS Lambda. AWS Lambda are mostly used for event-driven application for the data processing. Now let's see what are some of the use cases of AWS Lambda. The first one is file processing. So AWS Lambda can be triggered by using simple storage service, which is S3. So whenever you upload or create a new file on your S3, the Lambda service will trigger automatically, and it will process the data from your S3 bucket. The second use case could be a web application in which you can combine both the web application and the AWS Lambda, which will scale up and scale down automatically based on the incoming traffics. The third use case could be IoT applications, where you can trigger AWS Lambda based on certain conditions while processing the data from the device which are connecting to the IoT applications. The fourth use case could be where you can do the stream processing using Lambda. So Lambda function can be integrated with Amazon Kinesis to process real-time streaming data for application tracking, log filtering, and so on. Now let's see some of the features of AWS Lambda. So the first feature is it is auto scaling and high availability. So AWS Lambda will make sure that your application was highly available to the end user when there is a sudden increase of incoming traffic. So this high availability can be achieved by auto scaling the application, which is one of the features of AWS Lambda. The second feature is it's a serverless execution, so there is no need to provision the servers manually in AWS. So AWS Lambda will provision the underlying infrastructure. You just need to have your code deployed to AWS Lambda, and AWS will take care of everything in terms of deploying the infrastructure to execute that particular piece of code. The third feature of AWS Lambda is it's a pay per use pricing. So AWS will charge only for the time when the compute engine was active. It only bills you based on the time taken to execute the code. Uh, the other feature is that it supports different programming language. So you can write your program into different programming language. So these are the list of programs which is currently being supported by AWS, where you can use you can write the code in Python, Node.js, Java, she has PowerShell or Go based on your business requirement. The one of the important feature of AWS Lambda that it seamlessly integrate with other AWS service. So we can integrate with different AWS services like API Gateway, DynamoDB, S3, Step Function, SNS, and SQS. So these are some of the list of AWS services with which we can integrate AWS Lambda pretty easily. Now let's see how does AWS Lambda works. So the first step in any AWS Lambda is to you have to upload the code to AWS Lambda, and then from there you need to set up the code to trigger the AWS Lambda, which could be coming from any AWS services or an HTTP endpoint or mobile application. Uh, the third step is that AWS Lambda will run the code when it is triggered and will only use the computing resources needed to run it. And then the last is that user has to pay only the compute which AWS Lambda has used while processing the code. Now take an example here that we have an S3 bucket where we are uploading some of the photographs which we have taken. So as soon as you upload those photographs in S3 bucket, your Lambda uh, triggers automatically. And in the Lambda function, you have written a code which is going to resize the image based on your target application. So the photos can be resized into a web, a mobile, or tablet size based on the requirement of your business. So that functionality is being written into Lambda. And as soon as you upload the files in your S3 bucket, the functions triggers the code, and this process will automatically happen into your AWS Lambda. So this is how the AWS Lambda works. Thank you. Hello everyone. So in this video, we are going to see how do we create and use a Lambda function in AWS. So to create a Lambda function, simply log into your AWS Management Console, and in the search bar, search for Lambda, and you should be able to see Lambda. Just click it to open it. Once you are in the Lambda page, you should be able to see all the different functions what you have created. So to create a new function, simply click on create function. In the create function page, it will ask you to choose what type of Lambda you want to create. So the first option is you can create from scratch, where it starts with a simple hello world example. The second option is you use a blueprint which is already given by AWS to create a Lambda function. Or the third option is that if you have a container image of your function, you can use that image into your Lambda to create your function. So for this video, will select the option of author from scratch. In that, it will ask some basic information. The first is you need to provide a function name. So let's provide a function name. So this is going to be the function name for my Lambda. Now we have to choose the language in which you want to create this Lambda function. So as of now, AWS Lambda supports these different languages. So we have .NET, Java, Node.js, Python, Ruby, and Amazon Linux. So for this video, we are going to create this Lambda function in Python. So simply select the Python option. So you can see different versions of Python. So this is the latest version of Python what we have. So select any version on which you want to create your function. So I'll select the Python 3.9. Now the next option is it is asking you to select the architecture on which you want to
deploy your infrastructure. So currently we have two options. One is 86 by 64-bit architecture and one is ARM 64. So this is the default what AWS provide, and this is the other architecture which you can choose. So let's keep this 8664 architecture, which is the default one. Now in the permission, it will ask you to it will ask you to provide the execution role, which is going to be used while executing this Lambda. So Lambda is going to use that role uh, to process your the code what you have written in your Lambda. So there are three options what we have. The first is you can create a new role with basic Lambda permission. So when your function is created, what AWS does, it creates a new role which with basic Lambda permission, and that permission is only to write or upload the logs to your Amazon CloudWatch. The other one is if you already have an IAM role which you have created in your IAM, you can use that role to assign into your Lambda function, or you can create from any AWS policy template. So as of now, we don't have any role, so we'll go ahead and select this one, which is going to create a new role when the Lambda functions gets created. Now in the advanced setting, we don't have to select anything. So let's keep everything as default and click on create function. This is going to create your function in Lambda. So let's wait for some few seconds and it should be able to create your Lambda function. So once your Lambda function is successfully created, you should be able to see all the different informations about Lambda. So this is your ARN of the function. This can be used to access this particular Lambda function from any of the other AWS services. Uh, when you create a Lambda function, what it does, it by default provide you a sample code in the language what you have selected. So in this case, we have selected a Python, our language as Python. So it created a sample .py file, which is associated with this Lambda function. Now to execute this Python code, what you can do is you need to provide some event to this function. So the Lambda function and the Lambda code always start with this Lambda handler. So this Lambda handler is nothing but your execution entry point, right? So AWS Lambda needs to know where to begin executing your code, right? Once it triggers. So unlike any traditional Python scripts, what you write, it always start from top and proceed sequentially. But AWS Lambda requires a specific entry point defined by you, and this entry point, what we call is the Lambda handler. With the Lambda handler, you will have two parameters. The first is event. So event parameters contains the event data which triggers the Lambda function, right? So such as the HTTP request detail, which is comes from any API endpoints, or S3 bucket notification. Any event which is used to trigger this Lambda function, that information will be available in this event parameter. The second parameter is the context. So context is the parameter which provides runtime information about your Lambda function, such as the function name, the request ID, and many more. So this is a simple Python code what is already provided by default by AWS, where what we are doing is based on certain events, we are triggering this Lambda function where it is returning the status code, and the body in the body we have mentioned a hello from Lambda. So to test this function, we go to the test section, and here we need to create a new event. So to create a new event, simply select the create new event and give a name to your event. So let's give a name. So I'm saying that, okay, this is my event name, and this is the JSON which is going as part of this event. So once you save this, you can you can click on test to test the code what is being currently available into your Lambda function. So just click on test, and you should be able to see the function has successfully executed, and you should be able to see the logs what this function has written, where status code is 200 and the body we get a message of hello from Lambda, what we have currently into this particular Python code. So this is how you can test your Lambda. Now, if you want to monitor your Lambda function, you can come to your monitor section, and here you can click on to view CloudWatch. So this is going to give you the CloudWatch log group where all the different logs of this particular Lambda function will be stored. So this is how you can see and monitor uh, the progress of your Lambda in terms of the logs. This is the configuration section where you can see all the different configuration which is currently available into your Lambda function. So in the general section, you can see all the different parameters like memory, ephemeral storage, timeout, and snap start, right? So if you want to make any changes on this one, you just simply click on edit and change the values accordingly. So the memory can be minimum of 128 MB and maximum it goes to 10 GB. So you can change it accordingly. Ephemeral storage is nothing but your temporary storage, and you can configure up to 10 GB of ephemeral storage in your Lambda. So that's the hard limit. Uh, Now the timeout. So the timeout is maximum you can go up to 15 minutes. You cannot go beyond 15 minutes. So timeout. So maximum timeout is set up as default in Lambda is 15 minutes. So this timeout is nothing but if your Lambda function is executing, it should be able to complete within the timeout uh, threshold what you have given into your configuration, and maximum it can run up to 15 minutes. If your Lambda is running beyond 15 minutes, your Lambda function will fail. So we have to keep that in mind. Now, if you want to change your execution role, you can also change your execution role. But as of now, we are simply selected the one which Lambda function has automatically created with a certain simple permissions. So this is how you can change all the configuration. Now, the next section is triggers. So triggers are nothing but if you want to, because Lambda is an event-based trigger service, right? So if you want to trigger your Lambda from some events coming from different AWS services or different application, you can configure that over here, and whatever configuration you have set it up in your triggers, if the event comes from those services, the Lambda will automatically trigger. So if you want to add any trigger, you simply click on add trigger, and here you should be able to see all the different sources what you have, right? You can set up a trigger from any APIs or interactive webs like IoT devices, API Gateway, CloudFront, code commit, and all that, or you can set it up from any other AWS services like S3, SNS, and SQS also. So this is how you can set up any triggers in your Lambda function. In the permissions, you should be able to see the current role and what all permissions is given to this role. So this is the role which Lambda has automatically created. So if you open this role, you should be able to see a simple permissions where it is only given a permission to write or create log stream and put log event into the CloudWatch. So this is where you can see all the permissions. The destination is where if you want to set up some sort of destination in your Lambda function based on the execution status of your Lambda, saying that, okay, if it is success or a failure, I want to do certain operation with this Lambda. So you can add the destination. So if you want to add any destination, you simply click on add destination, and based on the condition on failure or success, you can choose different destination types. So currently we have 4 where we can send the message to SNS, topic, SQS queue, another Lambda function, or event bridge. So this is how you can set it up your destination. Now the next section is function URL. So function URL is nothing but if you want to expose your Lambda as an API that can be accessed through an HTTP request, you can create that access point into functional URL. If you want to create any variables, that can be done in the environmental variable section. If you want to attach any tags to your Lambda function, you can do in the tag section. Want to connect any VPC, like you want to connect your functions to any VPC, you can do in the VPC section. Similar to that, if you want to connect it to an RDS database, you can do over here in the RDS database section. In the monitoring and operation, you can see which is the cloud log which is currently associated with this Lambda function. So that information you should be able to see over here. Concurrency, this is going to be the place where you can see what is the current concurrency limit set it up on my Lambda function. So currently we have as default as 1,000 as a concurrency, where 1,000 instance of your Lambda can trigger on a parallel basis based on your business requirement. So if you want to make any change over here, you can simply click on edit and make any changes. Any information about your asynchronous invocation of your Lambda can be seen over here. Uh, the next is code signing. So code signing is nothing but if you want to digitally sign your Lambda function to verify its authenticity and integrity before it deploys to any AWS service, you can do over here. If you want to attach your Lambda to any file systems, you can simply come here and add the file systems. Or you want to trigger your Lambda function through any steps function in AWS, you can attach that step function over here. So these are different configuration on Lambda which you can make and change. Uh, Now in the alias section, so what is alias? So alias is nothing but if you want to create a named pointer or reference to your specific version of your Lambda, you can create that alias and use that alias to point to different versions of your Lambda code. And that those versions you can able to see in the version section. So every time when you publish a new version of your Lambda function, AWS assign a unique ARN or version numbers, and that information you should be able to see over here. Now, this is a default code what Lambda creates when you create a new Lambda function. Now, let's say if you want to change this code for your specific business need, how do you do that? So let's take an example that I have a JSON file. So this is my JSON file. So let's come to the test, and this is the JSON file which I have, which I'm going to create as an event. So I simply update the existing event where I change the JSON where I have name, age, and car, where all these JSON keys contain certain values. So I want to write a Python code which is going to read this JSON file and read all the tags from this JSON file and populate the values of those tags. So to do that, I simply update my test where I update the event and save this event. Now go back to the code, and in place of the default code, I will place my Python code which I'm going to use to read that JSON file. So this is my Python file where I am importing the library which is of JSON. I define the entry point of my Lambda, where what I'm doing, I'm printing the event and printing the context which is coming into this Lambda handler. And then what I'm trying to do is I'm trying to access each and every field of that JSON file, and I'm printing those information onto my terminal. So once you make the change in your code in your Lambda function, you have to deploy the change. Until unless you deploy your new Lambda code will not be updated. So simply click on deploy. Once it's successfully deployed, now your Lambda function has the current code, which is this one. Now to test it, simply click on test, and you should be able to see the log. So here, if you see this is the event which I have printed, which is this JSON which I have passed as an event, and this is the context where I can see different options like log group name, what is the function name, all those details are present over here. What is the MB in which limit, what is the latest version of that Lambda function. So all these Lambda context are printed over here. Now, if you see the log, here I am trying to read every fields from the JSON, and I was able to populate those fields into my terminal. So this is how you can update your Lambda code in the language what you have written, and test that functionality according to your Lambda. So this is how you create a Lambda function, uh, test the Lambda function, and make any configuration change, add triggers, or add destination accordingly to your Lambda function. Thank you. Hello everyone. So in this video, we are going to see what is AWS Step Function. Step Function is a service provided by Amazon Web Service that makes it easier to orchestrate multiple AWS service to accomplish different tasks. Uh, Step Functions allows you to create steps in a process where the output of one step becomes the input of another steps, all using a visual workflow editor. It also provides quite of a convenient functionality such as automatic retry handling, triggering and tracking of each workflow steps, and ensuring steps are executed in the order what you have defined. Step function are based on state machine and task. So state machine is nothing but entire workflow what you create into step functions. A task is a state in a workflow that represent a single unit of work that another AWS service perform. And each step in a workflow is a state. So if you see this diagram, this entire workflow from start to end is what we call as a state machine, and this is a workflow. In this workflow, you will have different tasks, and these tasks are nothing but any AWS service which perform these tasks, right? So you can add any AWS service such as Lambda, DynamoDB, SQS, or SNS based on your requirement. So step functions are a combination of your state machines and tasks. Now let's see how does step functions work. So this is a diagram where we are going to create a process for any checkout, a store checkout process using a Lambda functions. So when the user goes on a website and try to purchase something, this entire pipeline can be orchestrated through a step functions where when a customer select a product, the first Lambda is going to check that inventory whether that product is available or not, and if that is available, it is going to hold that product. So that's the function of the first Lambda. Now, once the first Lambda completes its process, the second Lambda kicks off in step function where it is going to bill the customer. So by using that Lambda function, you will bill a customer. If the billing does not go through on the first try, it will try it for the 2 or 3 times. And if that is also not going through, it puts a exceptional handling where it removes the hold of the product if the payment is not going through because of certain issue in the credit card and all that. So that will perform by the second Lambda. Now, if the billing of the customer goes through, then the third Lambda kicks off where it performs an activity where it ships the product to the given shipping address, right? And it notifies the human saying that your product is now shipped. So this is how you can create a store checkout process using Lambda function in a AWS step functions where each of these steps is dependent on the previous step and it automatically triggers when the previous steps gets completed. Now let's see some of the benefits of AWS Step Function. So since AWS is a low-code visual workflow service that developers uses to build distributed applications, automate any IT and business processes, and build data machine learning pipelines using different AWS services. It also helps you in managing failures, retries, parallelization, service integration, and observability. So that developer can focus on higher value business logics. So some of the benefits of using AWS Step Function are it is easy to connect with a workflow editor and hence less code will be written because everything will be done through a visual editor. It is very easy to integrate with other AWS services such as SNS, SQS, Batch, and Fargate. It automatic scaled based on the workload of your pipeline which you are going to set up into step functions. It also manage state checkpoints and restarts to make sure that application executes in order. It can handle errors, rollbacks, and retries. Also, logs each state, and it is easier to work with that. So these are some of the benefits of using AWS Step Functions. Now let's see some of the use cases where you can deploy AWS Step Function. So the first I can think of if you want to automate extract, transform, and load, which is the ETL process, you can use Step Function, which is going to ensure that multiple job running ETL jobs can run in an order to complete successfully without needing of any manual intervention or orchestration. It is also used in orchestrating microservices. So we can combine multiple AWS Lambda function in a responsive serverless application and microservices by using AWS Step Function. It also orchestrates large scale parallel workload. So it can iterate over and process large data sets such as security logs, transactional data, or images and video files. The last use cases where we can deploy a step function is it can automate security and IT functions. So we can create an automated workflow, including manual approval steps for security incident responses. So these are some of the use cases where we can use AWS step functions. Thank you. Hello, everyone. So in this video, we are going to see what is AWS Kinesis. AWS Kinesis is a service provided by Amazon Web Service that allows user to process a large amount of data per second in real time. It is used to analyze streaming data and process it for further use at large amount of scale. It is fully managed by Amazon itself, so it is easy to capture, process, and store streaming data in the cloud. It is also very useful for the developers to build application by which they can continuously ingest, process, and analyze data stream from various sources such as applications and service logs, clickstream data, sensor data, or any in-app user events. Now let's see how AWS Kinesis works. So AWS Kinesis works on 4 steps. The first is the data ingestion. Uh, the Kinesis will collect the data or receive the data from different data streams like applications, sensors, and so on. After it ingests the data, the second step is sharding and scaling. So the data which it received from different sources are divided into smaller shards for redundancy and fault tolerance. There is currently no limit on the shards in Amazon Kinesis. It can scale the shards horizontally depending on the requirement. Now the third step is it process and buffers the data. So after sharding, the data will be prepared for the further use. The fourth step is making the data accessible. So after completing all the above steps, the data should be accessible in various way to assess and utilize. Now let's see what are different services which is currently offered by AWS Kinesis. The first service it provides is called Kinesis Data Stream. Uh, the Kinesis Data Streams provides a platform for real-time and continuous processing of data. The second service we call as Kinesis Data Analytics. It allows the streams of data provided by Kinesis streams to analyze and process it within standard SQLs. The third service what is provided is we call as Kinesis Data Firehose. So Firehose is going to help the user to reliably capture, transform, and load streaming data into other AWS data stores and analytics services. Now, take an example of the below architecture where we can use all the services provided by Amazon Kinesis, where we have a website which is sending the clickstream data, and that data is will be captured into Kinesis data streams. Once the Kinesis data streams collects the data, it sends to Kinesis Data Analytics, where you can process the data in real time. Once the data is processed into your Kinesis Data Analytics, it will send the data to Kinesis Data Firehose, where the processed data will be loaded from your Kinesis Data Firehose to Amazon Redshift. And in the Amazon Redshift, you can run analytics models to come up with content recommendations, and those recommendations will be seen by the users on a real time, and they can engage more. So this is an architecture where you can deploy all the different services offered by AWS Kinesis. Now let's see some of the features of AWS Kinesis. The first feature is cost efficient because it follows pay as you go model. So you have to pay for the services according to the use, not a flat price. It also integrates with other AWS services very efficiently. That is one of the important feature of AWS Kinesis. The third feature is availability. So you can access it from anywhere and anytime since it is an AWS cloud. Uh, the last feature is it helps you in real-time processing. So it allows you to work with upon the data which is needed to be updated every time with changes in real time. Now let's see some of the use cases where you can use AWS Kinesis. The first is the real-time application monitoring. So it provides the real-time data for any application where you want to see or where you want to monitor that application on the real-time basis. The second is it helps you in fraud detection and prevention. By analyzing the transactional data, we can help you detect the suspicions patterns and blocks fraudulent transaction before it happens. It also helps you in personalized recommendations and marketing. So Amazon Kinesis will help you in analyze the data of the customers, by which you can understand your customer very better, and you can recommend the personalized product in real time to the customers. The last use case where you can think you can deploy AWS Kinesis is IoT analytics and predictive maintenance. So your connected gadgets full potentials can be unlocked with Kinesis through the examination of sensor data from electronics and mobiles and machinery. You can have the predictive maintenance of these applications or tools. So these are some of the use cases of AWS Kinesis. Thank you.
Hello everyone. So in the previous video, we have discussed about what is AWS Kinesis and how it works. Also discussed about different services provided by AWS Kinesis. So in this video, we will discuss about one of the AWS Kinesis service called Kinesis Data Stream. So Kinesis Data Stream provides a platform for a real-time or continuous processing of data. So in this video, we will see how we create a Kinesis data stream in AWS and how it can be used to process real-time data using a Python programming language. So to create a Kinesis data stream, simply log into your AWS Management Console, and in the search bar, you can simply search for Kinesis. You should be able to see Kinesis option here, or you can directly search for Kinesis data stream and just click it to open it. So just click on Kinesis data stream and you should be able to land into Amazon Kinesis page, where you can see different options of creating data stream, data firehose, Apache Flink. So to create Kinesis data streams, simply click on data streams and you should be able to see an options to create a data stream. So just click on to create the data stream. In the configuration page, it will ask you to provide a data stream name. So let's provide a suitable name to that stream. So this is the name which I'm going to provide, which is the Academy stream. The next section, it will ask you to provide the capacity of this data stream. So there are currently two modes which is available in AWS. One is on demand and one is provision. So on demand is used when you don't know the requirement that how much data you are going to process through AWS Kinesis. So if you don't have the requirement captured with you, then you can click on demand and use this particular option in the capacity mode. If you know that how much data you want to process based on certain estimates, you can use this provision and then change the shards according to your requirement. But the recommendation is always go on to select the on-demand option. So let's select that, and it will show you the read and write capacity of this particular data streams based on the on-demand mode. So you can write 200 MB per second or 200K records per second, and the read capacity, it can read 400 MB per second out of your data streams. So the rest everything will be same. So the data retention is by default 1 day, which is 24 hours here. We will not provide any encryption. The monitoring enhancement mechanism is disabled. So let's keep everything as default and click on create data stream, and they should be able to create a data stream for you. So let's refresh the page and you should be able to see the status is active. So you can see the ARN of this data stream. So this is the ARN, this is the name of your data stream. So in the application section, you can see different producers and consumers which you can create. So the producers are nothing but from where you can write the data to this Kinesis data stream. So those will becomes producer. So these are few of the options which is by default given by AWS, like Amazon Kinesis Agent, AWS SDK, or Kinesis Producer Library. There are a few lists of the consumers also present over here. So consumers are nothing but which are going to be used to consume the data from the AWS Kinesis data streams. So we have Manage Apache Flink, we have Data Firehose, we have Kinesis Client Library. So these are under the application section. In the monitoring, This will show all the different graphs. Whenever you push the data, it will show that as a graph inside your Kinesis data stream. In the configuration section, then you will see all the configuration what you have provided. So the capacity is on demand, what is the write capacity, what is the read capacity of this data stream. You can check over here. You can see also if you have provided any tags to your data streams, any encryption which you have applied, what is the data retention applied on this data stream. So all these information you can see in the configuration section. The data viewer, this is option where you can check, you can view the data which is sitting into data stream. So that we will see once we push the data into this data stream. The data stream sharing. So this is where you can share the data with other people or other applications. So here you can create the policy accordingly and then share the data with that. So now once you create the data streams, now let's see how do we push the data into this particular data stream. So for this video, I'm going to use a Python code, which is going to push a JSON file into this data stream. So this is my Python code what I have, where I am trying to log in with the access key, secret key, and the region name to my AWS account. And then there I am creating a session where by using these credentials, and then I am setting a client which is the Kinesis client, and here I need to pass the stream name what you have created. So let's take the name of the stream. So this is the name of the stream which I have. So simply copy that and go here and change your stream name. So this is the stream name where I want to push the data. Now this is the sample data which I am going to pass. So this is a very simple where we have a tag and a value which we want to send to our data stream. And once we have, then we are dumping that as a JSON, and then we are putting this data put record. Put record is one of the actions where you can put the data inside your Kinesis data stream. So by using this put record, we need to provide the stream name where we want to push the data which you want to push it, and the partition key. So the partition key is by default we have used the first partition key. So let's execute this code and see if the data goes and right into. So this is the response what we have got it from the Kinesis data stream, where after the successful execution, the status code we received is 200. That's this language, this program has successfully written the record or the JSON into your data stream. So let's go back, and it will provide you the shard detail, that this is the shard, that this is the partition where the data has been written to your Kinesis stream, and this is the sequence number from where it has started writing the data. So now let's see and go back to your data stream and try to see if you can view this data into your data viewer inside the data stream. So in the monitoring section, if you go, and you should be able to see there is one record which has been written, put record. So let's wait for some time. It will refresh in some time. Okay, but let's go and check the data viewer first. So here you can choose the shard and the starting position where the data is being written to. So take this shard here, copy this shard, go back to your data viewer and select the shard which is this 003, and here starting position you can select the add the sequence number. So just take the sequence number from here, go back to your code, and this is the sequence number, and just click on get record. So here you see this is the data which you have pushed from the Python to your Kinesis data stream, and the data is now setting into your Kinesis data stream. So this is how you can use any language or any application to push the data to your Kinesis data streams. Now in the next video we will see how do we read the data from your Kinesis data streams to by using a Kinesis data Firehose, and then from that Firehose we will try to write this data to your S3 bucket. So this is how you can create a data streams, use that data streams to write the data or store the data, and then in AWS. Thank you.
Hello everyone. So in the previous video, we had discussed about what is AWS Kinesis data stream and how it works. We also post as JSON data to this particular data stream by using a Python code. Now in this video, we are going to discuss about the other AWS Kinesis service called Kinesis Data Firehose. So Kinesis Data Firehose helps the user to reliably capture, transform, and load streaming data in AWS data stores or any analytical service of AWS. So in this video, we will see how to create a Kinesis data firehose, and by using the same, how can we write the data from our Kinesis data stream, which we have created in the previous video, to a S3 bucket. So now to create a Kinesis data firehose, simply log into your AWS Management Console, and in the search bar, type for Kinesis, and you should be able to see the option of Kinesis. Just click it to open it. So once you are in the Amazon Kinesis page, you should be able to see on the left hand side an option of Amazon Data Firehose. So just click on this one and you should be able to open the Amazon Data Firehose page where you can create the Firehose streams. Now, before that, let's go back and open the data stream what we had created already. So if you click on data stream, you should be able to see the Kinesis data stream which you have already created. And in this data stream, we pushed a data through a Python code. So the data is setting into this Kinesis data stream. Now, if you want to read this data from this Kinesis data stream, if you come to an application, there are some consumers which AWS provides. So one of the consumer is Amazon Data Firehose. So this is one of the consumer which should be able to read the data from any of the Kinesis data streams, and that's why we are going to use this Firehose to read the data from this particular stream and write to an S3 bucket in this particular use case. So let's go back to your data firehose page, and to create a new data firehose, you just click on create firehose stream. So once you are in the configuration page, you should be able to see what is the source from where you want to select the data. So this is the so we want to read the data from Amazon Kinesis data stream. We have other two options, which is Amazon MSK, which is managed services of Kafka, and the direct port. So let's click on Amazon Kinesis data stream. Now for the destination, it will give you different options, like you can write the data to Amazon Redshift, which could be an analytical service of AWS. You could write the data to an S3 bucket, which could be a data store for AWS. We have other options like you can write to Splunk, you can directly write to Snowflake, you can write to MongoDB. So all these different options we have here. But as of now, we'll write this data to an S3 bucket. So simply select an S3. Now, once you select the S3, it will ask you about the source setting, which is from which Kinesis data stream you want to read the data. So you just need to click on browse, and whatever data streams you want to select, that you just select that and click on choose. So this is the data stream from where we want to read the data in this Firehose. Now it will the AWS will automatically create a name for your Firehose. So this is the by default name what it has created. But if you want to change this name, you can change it accordingly. But let's keep this as a default. Now in the next section, it's asking you to transform and convert record. So this is an optional configuration what you can apply into AWS data Firehose. So if you want to transform the source data, do any sort of transformation using an AWS Lambda, you can just turn on data transformation and select the Lambda through which you want to do it. If you want to change the record format, you can do over here. If you want to decompress the source data, you can do it here. Let's keep everything as an optional. Now in the destination setting, so our destination is an S3 bucket. So it is asking you to select the bucket where you want to write the data. So let's click on browse and select the bucket where you want to write. So this is the bucket where I want to write this data. So click on choose. Now other options where it asking you to provide if you want to have a new line delimiter, the default is not enabled. So let's keep that one. If you want to perform a dynamic partitioning, you can enable or disable it automatically. Uh, S3 bucket prefix. So if you want to write this data to any particular folder inside your bucket, so then you can provide that folder name over here. But if you don't provide any folder name, it will automatically prefix with the YY, MMDD, and HH format into your bucket. So let's keep that as an optional. The error output prefix also will be optional. S3 prefix time zone, as of now you'll have different, but we'll keep the default as UTC. Now click on the buffer hints and compression section. So this is the place where you can change the configuration of your data firehose, where you can apply the different buffers. So one is based on the size and one is based on the interval. So the minimum is like 1 MB and the maximum is 128 MB, and the recommended by AWS is 5 MB. So the Firehose will not write the data to any S3 bucket or any target destination what you have chosen until the buffer size reaches to whatever the number you have given over here. If you've given a 5 MB, so until the data reach 5 MB, the Firehose will not write the data to your destination. So this can be changed accordingly. So let's keep this as a minimum, which is 1 MB, and the interval. So other option is you can give an interval. Here you can go from 0 seconds to maximum of 900 seconds. So the buffer interval is nothing but whatever time you have given. If the time is not reached till that seconds, the Firehose will not write the data to your destination bucket, right? So it chooses either the size or the interval, whatever comes first, whether your size of the data becomes 1 MB, or what if the data has not become 1 MB, then if the buffer interval has reached to whatever interval you have given, let's say you give 5 seconds. So if your 5 seconds comes before your data becomes 1 MB, then the Firehose will write the data to your destination bucket. So this is how you can control how do you want to write the data to your destination accordingly from the Firehose. So let's keep a minimum of 1 MB here, and here we'll put a 0 because we just want to quickly write the data to our S3 bucket. But this can be changed according to the business requirement. Now, this other option is compression for the data record. So if you want to apply any sort of compression on your data which is written to S3 bucket, you can choose if you want to zip the file, if you want to have a snappy compression, so you can do that. But as of now, we'll keep as not enabled. File extensional format, if you want to apply any extension to your file, it could be a JSON, zip, GZ, you can apply over here. The next option is, do you want to encrypt the data? So we will use the default one, which is going to be the S3 encryption, which is going to apply to this particular bucket. But if you want to encrypt your data with any of the KMS key, you can just select that option here and choose the KMS key through which you want to encrypt the data. So let's choose the default one. Now, in the advanced setting, we'll keep everything as default, and then we will click on create Firehose stream, and this is going to create a Firehose stream in your AWS account. So let's wait for some time till it creates the Firehose. So once it's successfully created, you should be able to see your Firehose created over here, where you can see the ARN of the Firehose. The status is active. And in the configuration, you can choose see all the different configurations. So this is the data stream from where you are writing the data to this Firehose. Uh, these are the destination what you have given. This is the bucket where you want to write this data from your Firehose, and these are the different buffer limits what you have applied onto your data. So once your Firehose is created successfully and connected to your data streams, now let's go and check if you write the data to your Kinesis data stream, should it automatically writes to your S3 bucket. So first, let's open the S3 bucket and see what do we have in that bucket. So I open the S3 bucket, and this is the bucket where I am trying to write. So as of now, this bucket is empty. Now let's use the same Python code what we have used previously while creating the AWS Kinesis data stream, where what we are doing is using this Python code. What we are doing is we are writing this particular JSON data into this data stream, and this is the data stream which is now attached to a Kinesis data Firehose. So if you see here, this is the data stream which is now connected to your Firehose stream. Now if you push this data will flow to your Kinesis data stream, and from Kinesis data stream, the Firehose will read the data, and then it will write the data into this S3 bucket. So this is how you can write the data. So now let's go back and execute this code. Now it is successfully write the data to your Kinesis data stream into this shard and this sequence number. So let's go back and check in your Kinesis data stream. So if I go back to my Kinesis data stream and go to data viewer and select the shard, which is this 003, and this is the this is the sequence number where this data is being written. So just copy this one, come back to your Kinesis data stream, select the add sequence number and give the sequence number and click on get records. So this is the same JSON file which we have given into my Python code, and this is the same which has been written to my Kinesis data stream. Now let's go back to our Kinesis data Firehose and see. It will take some time to actually write the data to Kinesis data stream. Kinesis data Firehose. So let's wait, and meanwhile we'll go back and check our S3 bucket. So we'll wait for some time, and after a few seconds, because that's the buffer what we have given, after a few seconds the data should be automatically written to our S3 bucket. Now if you see, the data is now written to your bucket from the Kinesis data Firehose, and if you see, it has written the data into the folder where you have the year, you have the month, you have the date, and you have the hour, and in that you have this data which is actual the data what you have pushed from your the Python code. So let's try to download this file and see what is the content in this file. So once you download it, just open this file. So I'll just open this file from in my local wherever I have downloaded it. I can show you this. This is the data what I have uh, copied from the file which I have downloaded from S3 bucket. So this is how, by using the Kinesis data Firehose, you should be able to read the data from any Kinesis data streams and write to any destination where you want to write the data. In this case, we have used S3 bucket, but you can have different options of AWS services where you can write the data by using the Firehose in AWS. So this is how we create a data Firehose and use it to write the data to different AWS services. Thank you. Hello everyone. So in this video, we are going to see what is AWS API Gateway. Amazon API Gateway is fully managed by Amazon Web Service, which makes it easier to publish, maintain, monitor, and secure APIs at any scale. APIs act as a server between your client application and backend services. So if any client makes any API request, they have to go through this API Gateway. API gateways are also responsible for routing the request from client side to the appropriate services, as well as performing other tasks such as authorization, authentication, and traffic management. So these are some of the features which makes AWS API Gateway more powerful. The first, it helps in traffic management. It also performs the authorization, authentication, and access control. It helps you in throttling, load balancing, and caching. Now let's see how does API gateway works. So API gateway endpoint received a request from your client. So the client could be any applications or any devices. So once the request comes to API gateway, it routed it to the relevant backend services by API gateway proper services. So whichever backend services the client wanted to access, that request will be routed according to that particular service. After processing that request, the backend services provide a response. Then the client receives the response from the API gateway. So whatever processes the backend services complete, it sends a response back to API gateway, and then API gateway sends the response back to the client. So this is how the API gateway works. Now let's see what all different types of API does API gateway supports. The first is the REST API. We call as a representational state transform. It's an architectural style that defines a set of constraints to be used for creating web services. Uh, it's a way of accessing web services in a simple and flexible way without having any processing. The second is a SOAP APIs, which we call as simple object access protocol. It is a network protocol for exchanging structured data between nodes. The last one is the WebSocket API. So Web API is an API, as the name suggested. It can access to over the web using HTTP protocol. So it is a framework that help you to create and develop HTTP based RESTful services. So these are the different APIs which AWS API Gateway supports. Now let's see some of the benefits of using an AWS API Gateway. The first is the simple to use. The AWS provide a very simple UI to use API Gateway, which makes it very easy to create or manage or monitor any APIs. The second is it's very scalable. So it's a highly scalable API Gateway that can handle any heavy demands based on the workloads. The third is it's a very secured because it offers several capabilities like custom authorization and IAM integration in AWS, which helps to secure any APIs what you build on AWS API Gateway. The last one is expose backend services. So we can expose several backend services to the external clients such as web application, mobile application, or any other APIs through by using an API gateway. So these are some of the benefits of using AWS API gateway. Thank you. Hello everyone. So in the previous video, we have seen an overview of what is API gateway in AWS. Now in this video, we are going to see how do we set up API gateway in AWS. And then we will use that API gateway to upload files sent from a third-party application called Postman to an S3 bucket. So to create an API gateway, first log into your AWS Management Console and in the search bar, type for API gateway. Once you see, just click it to open it. So once you are in your API gateway page, you should be able to see all the different APIs what you have created. Or if you are creating for the first time, you come to the API page here and click on Create API to create a new API. So just simply click on Create API. And here you will see different types of APIs what you can create in API gateways. So first is HTTP API, WebSocket API, REST API, and the REST API private. Now in this video, we are going to create an REST API. Because this is the API which has a complete control over the request and response with the API management. So you can send information through internet using the REST API. So to create a REST API, simply click on build. Now here it will ask for some of the details regarding the API. So first you can create from scratch a new API or you can clone an existing API. If you already have an API configuration, you can just import that API configuration, or if you can click an example API, the AWS API Gateway will provide an example API. So let's go with the new API option. So just select that and give a name to this API. So in this API, we are going to upload files to an S3 bucket. So let's give a name something like that. My S3 API. Okay. Description is an optional, but you can give it. And the endpoint is always going to be the regional. So keep that as a default and click on Create API. So now once you click on Create API, it will come to the page where you want to, it will ask you to add the resources. So resources are nothing but the paths which is going to be part of your invocation URL of an API. Okay, so to first let's add the resources. To add a resources, you simply click on create resource, and here you need to give a name to that resource. So let's give a name. So first, while uploading to an S3, you need to have a bucket. Okay, so let's give a bucket name, and this bucket name we will give in a curly braces because uh, it needs to be override while sending the files from an postman, right? So if you give the bucket name something like that as a parameter, right? In the parenthesis, you should be able to override that while sending the request from your postman request. So let's give that as a bucket name and then click on create resource. It will create a bucket inside your the root folder, and then again after the bucket you need to have a file name, right? Because that file name which you are sending needs to be stored as a respective file name into your bucket. So let's create another resource under the bucket. So click on create resource, and so it is asking to put inside the bucket name folder. So let's give the name as file name. And here also we'll give this in the curly braces because we want to override this value while sending the request from the API, third-party API. Okay, so this is the name. Okay, now under the bucket name, you have the file name. Now click on create resource. Now, so under the bucket, you have your file name. Now under the file name, we need to create the methods. Okay, so the methods are nothing but the different actions what you perform in API gateways, such as put, delete, post, and all that, right? So to create a method, you simply click on create method here. Okay, and here in the method section, you need to choose what type of method you want to perform. So since we are planning to upload a file into an S3 bucket, so that action is a put. Okay, so let's select the put action, and here it is going to ask you what type of integration what you want to perform. So API gateway can integrate with many AWS services such as Lambda function uh, or any HTTP request, existing HTTP point it can integrate, or any mock API gateways mappings it can integrate, and it also can integrate with other AWS services. So since we have to integrate that with S3 bucket, simply click on AWS services, and here you need to the you need to choose the region where your S3 bucket is exists. So my bucket is in US East 1, so I'll simply select that. You select wherever your region is. Okay, now in the second you need to select the service. So my service is S3, so this is S3 simple storage service, so just select the S3. Domain we don't have to. The HTTP method is going to be the put, so simply select the put method. And now in the action type, you want to use this path override, right? So since the bucket and the file names, we are going to send it as part of the request which is coming from the postman, we need to override those. So simply select the use path override and give the path override. So we have to give bucket name slash our file name. So this is the this is the details which is going to come from the postman, where in place of the bucket name we will actually pass the actual bucket name, and in place of the file name we will actually send the file name, which is going to come here and override these two parameters. Okay, now in you need to have an execution role which is going to have an access to upload the files into your S3 bucket. So let's go ahead and create a role which is going to have access to perform these activities on S3 bucket. So to create a role, let's go ahead and search for IAM. Okay, so open that IAM. Now in the IAM, once you come to the role section, click on roles and click on create role. Okay, now in this, you want to use this AWS IAM role into API Gateway. So that's one of the AWS service. So simply select the AWS service option in the trust entity type and choose the search for API Gateway. So you should be able to see API Gateway. Click on that, and now click on next. Here by default it will add a default permissions where this API gateway can push the logs into CloudWatch logs. So let's go ahead with that and click on next. And now we need to give a role name to this role. So let's give a role which is going to be API gateway S3 role. So let's give this role. Now, this is the trust policy where API gateway should be able to assume this role to perform the activities on S3 bucket. Now, once you review everything, you click on create role. Now your role is created. Simply search for that role. Okay. And open this role, which is API gateway S3 role. And now we need to attach a permission in this role to perform certain activities on S3 bucket. So let's click on add permission and click on attach policies. In the policy section, then search for S3 full access. Okay, so you should be able to see already AWS manage policy. So simply select that policy and click on add permissions. Now your policy should be attached to your role which you are going to use in API Gateway. Now we need to pass the information of this role into our API Gateway. So we need to select the ARN. So this is the ARN of this role. So simply copy this ARN, come back to your API Gateway and put the ARN into the execution role. So simply copy paste that. So this is my role. Now uh, in the method request setting, you don't have to update anything. In the request path, you don't have to put anything. Now come back to the now let's keep everything as default, okay, and click on create method. Okay, now your method, your resources, everything is now successfully created. Now we come to the integration request where we have integrated this one with our S3 bucket. Okay, and we need to have the URL path parameters since we are passing the bucket names and the file name as parameters, which is getting override while the request comes from the postman. We need to update this URL path parameters. So let's click on edit. Okay, and in the URL path parameters you need to add the path parameters. So let's first do bucket name. Okay, and mapped from where it needs to be mapped, right? So this is going to be the value which is coming from your bucket name. So this is the value where the method and the request and the path, which is the bucket path name, is going to get override into this URL path parameter. Okay, now again let's add another one which is going to be the for the file name. So this is going to be the for my the file name. So simply the same thing what we have to do is like we have to have method plus dot request dot path dot file name. So these are the two URL path parameters which is going to come from your request from Postman, and that gets override as bucket name and file name. Okay, so once you add these ones, click on save. Okay, now you should be able to see. So you have the bucket name, which is going to come from a map from the path and the bucket name, which is come from your Postman, and also the file name. Okay, so now once you create your API gateway, you need to deploy this API gateway. Until unless you deploy this API gateway, you should not be able to communicate or use this API gateway through any of your applications. So to deploy this, you simply click on deploy API. So click on deploy API, and here it will ask you in which stage you want to deploy this API gateway. So you can create a new stage. So let's click on new stage and give a name like test. So this is the stage where I want to deploy it. And now click on deploy. Okay. Now your API gateway is now successfully deployed, and this is the URL which we are going to use to send any information to our API gateway, which is this. And from here, then we will send the files or the data to our S3 bucket where we want to upload those data set. So now let's open a new tab in our Google Chrome and search for Postman Online. So Postman is nothing but a tool through which we can call in any APIs. So once you are in Postman, you create a account. So since I already have an account, so I have log into that account, and you come back to the workspace and click on my workspace. If you don't have the workspace, you just configure your workspace. So once you are in your workspace, click on new. Okay, and select the HTTP because we are going to call an HTTP request from this Postman. select the HTTP and then select the method. So in this one, we are going to use the put method, right? Because we want to put the files into our S3 bucket. Now it is asking you to put the URL. So simply come back to your API gateway and copy this invoke URL. So copy this thing and come back to your Postman and paste it over here. Now this is the URL till the stage what you have where you have deployed your API. Now, after that, if you see, we have the bucket name and you have the file name. So let's pass the bucket name in which we want to upload this file. So simply in the search bar, search for S3 and open your S3. Now in the S3, you will select the bucket where you want to upload this file. So I am going to select this bucket. So this is the bucket where I want to upload this file. So copy the bucket name and come back to your Postman and put a slash and pass your bucket name. And then you want to pass the file name which you are going to use while uploading the file to your S3 bucket. So I have a CSV file which I want to upload into my S3 bucket. So I will give the name of the file name. So this is the file name which I want to give while uploading this file to my S3 bucket. Now, so these are the two parameters which we are passing from our URL, which is going to get override while we set up the API gateway. So these are the two parameters which are getting override while sending the request from our Postman. Now, once you pass the URL, you need to attach the file which you want to upload to your S3 bucket. So simply come to your body and then select the binary. And here you need to select the file from your local system, whichever file you want to upload. So select the file, click on new file from local machine and select the file. So this is the data.csv which I want to upload into this bucket as name.data.csv. Now click on send. If everything is set up correctly, you should be able to get a status of 200, which is the OK status. Now let's come back to our S3 bucket and try refreshing to see if the file has been uploaded or not. If you refresh it, you should be able to see the file is successfully being uploaded from Postman through an API gateway to our S3 bucket. So this is how you create APIs in API gateway and use those APIs to send information to different services on the backend in AWS. Thank you. Hello everyone. So in this video, we are going to see what is AWS CloudWatch. AWS CloudWatch is a monitoring and observability service provided by Amazon Web Service that enables users to collect and track metrics, monitor log files, set alarms, and automatically react to any changes happen in any of the AWS resources. It also helps users to gain insight in their operational health, performance, and resource utilization of their AWS infrastructure and applications. It collects monitoring and operational data in the form of logs, metrics, and events, providing its user with an aggregated view of AWS resources, application, and services that runs on AWS. It can be used to detect anomalies behavior in the environment, set warnings and alarms, visualize logs, metrics side by side, takes automated actions and troubleshoot those issues. Now let's see what are some of the features available in AWS CloudWatch. The first is CloudWatch dashboard. It is nothing but a console which is used for monitoring resource in a single view. There is currently no limit of number of CloudWatch dashboards what we can create, and these dashboards are global, not a region specific. The second feature is what we call as CloudWatch agent. It is required to be installed and on the service from where we are trying to capture the logs. It collects logs and stream level metrics from EC2 instance or any on-premises servers. Now the third is CloudWatch event. Uh, so an event indicates in AWS any change happens on your AWS environment. So whenever there is a change in the state of any of the AWS resource, the events are generated. And these events can be routed to one or more targets like AWS Lambda, Amazon SNS Topics, Amazon SQS Queue, and other target types. You can define rules that are used for matching events and routing those to the respective targets. The fourth one is is CloudWatch Log. It enables you to store, monitor, and access files from different AWS resources such as Amazon EC2 instance Route 53. It also helps you to troubleshoot your system's errors and maintain logs in a highly reliable storage. Now, let's see some of the benefits of using AWS CloudWatch. The first one is that CloudWatch acts as a dashboard that contain the organized collection of the whole data coming from different applications which are running on AWS. It also improves the total cost of ownership by providing alarms and also take automated actions when there is an error in the limit provided. Applications and resources can be optimized by examining these logs and metrics data which is being stored in the AWS CloudWatch. Another benefit is that it provides you a detailed insights from your application, such as CPU utilization, capacity utilization, and memory utilization. It also provides a great platform to compare and contrast the data produced by various AWS services. So these are some of the benefits of using AWS CloudWatch. Now let's see some of the use cases where AWS CloudWatch can be deployed. It can be used to monitor the performance of AWS resources, application, and infrastructure components in real time. It allows user to set up alarms that trigger notifications or automated actions in response to changes in the state of their resources. It can be used to store, search, and analyze log data from different AWS services, application, and infrastructure components. One of the use case, it can be used to monitor the performance of your EC2 instance, RDS database, and other resources, which can be used to trigger automatic scaling events. So these are some of the use case where we can deploy AWS CloudWatch. Thank you. Hello, everyone. So in this video, we are going to see what is AWS Athena. AWS Athena is a serverless query service that analyzes data which is present on your S3 bucket using standard SQL. With a few clicks in the AWS Management Console, you can point your Amazon Athena to the data which is stored in S3 and run queries using standard SQL to retrieve result in seconds. With Athena, there is no need to set up infrastructure and manage it, and the customer are going to only pay for the queries which they are going to run. It also scales automatically, executing queries in parallel, giving fast results even with the large data set and complex queries. Now let's see some of the features of AWS Athena. So the first is it's very easy to implement. It does not require any installation. And it also can be accessed by the AWS CLI directly from the AWS console. The second feature is it's a serverless. So the end user does not need to worry about setting up the infrastructure, configuring or scaling or any failures. Everything is taken care by Athena itself. The third feature is you pay per query. So Athena charges you only for the queries which you are going to run. That is the amount of data managed by per query. So you can save a lot if you can compress them and format your data set accordingly. The fourth feature is it's a very fast. So it's a very fast analysis tool. It can execute complex queries quickly by breaking them down into simpler queries and running them in parallel. The last feature is very secure. So with the help of IAM policies and AWS identities, Athena gives you complete control over your data set. So these are some of the features of AWS Athena. Now let's see where which all use cases are there where we can implement AWS Athena. So the first is any ad hoc queries and exploratory querying. So it's a very well suited for any ad hoc analysis you want to do quickly on your data set which is sitting on your S3 bucket without need for setting and managing infrastructure. Uh, the second use case, it can be used for a log analysis. So Athena is extensively used for log analysis, allowing customer to query massive amount of data sitting on your S3 bucket. The third use case, it can be used is like business intelligence. So by querying data stored in S3 and viewing the result in popular BI tools such as Tableau and Power BI, Athena may be used to serve business intelligence application. So you don't have to create the dashboards in Power BI or Tableau. You can use Athena to query the data sitting in S3 and do your business intelligence on top of that. So these are some of the use case of AWS Athena. Now let's see some of the limitations what we currently have in AWS Athena. Optimization of the queries is limited in Athena. Uh, so whatever data you are setting already stored in S3 cannot be optimized. So you just need to run the queries on top of that. There is no indexing what you can do in AWS Athena. Store procedures, parameterized queries, all these are not currently supported by AWS Athena. Uh, when you querying a table with thousands of partition, Athena can timeout. So any complex data what you have on S3, which has multiple thousands of partitions, when you are running a queries with Athena, it can timeout. Any DDL or DML operation like create table, describe input, describe output, merged or updates are not supported by AWS Athena. So these are certain limitations of Athena. Thank you. Hello everyone. So in this video, we are going to see what is AWS DynamoDB. AWS DynamoDB is a serverless key value and document database that offers seamless scalability and low latency performance. Unlike any traditional relational databases, DynamoDB does not require you to provision hardware or manage any infrastructure. It also allows users to create database capable of storing and retrieving any amount of data and serving any amount of traffic. It also automatically distribute the data and traffic over servers to dynamically manage each customer request and also maintains fast performance. Now let's see some of the features of AWS DynamoDB. The first is scalability. So DynamoDB can handle millions of requests per second, making it suitable for application with very uh, large levels of traffic. High availability, designed for a high availability and data durability with built-in replication across multiple availability zones of AWS. It's a managed service, so AWS take care of operational overhead, including hardware, provisioning, patching, and backup, so allowing you to focus only on building your own applications. Uh, it has a flexible data model, so DynamoDB supports both key value and the document data models, so provide flexibility in how you want to store your data inside the DynamoDB. The another feature is a cost saving. So DynamoDB is a serverless architecture. So coupled with its automatically scaling capabilities, allowing you to optimize cost by paying only for the resources which you are going to consume. The last feature is security. So with the help of AWS IAM integrations, it enables file-grained secured access control to your database resource at item and attribute level. So these are some of the features of AWS DynamoDB. Now let's see where all we can use AWS DynamoDB. So first, if you want to build a serverless application, DynamoDB is a de facto database for powering web and mobile backends for any e-commercial, retail, education, or media verticals. If you have any high volume special events where such as national electoral campaigns, you can implement DynamoDB in those particular use cases. Any social media applications, so community based applications such as online gaming platforms, photo sharing platform, location aware applications, where we have unpredictable uses pattern with the potentials to go viral anytime, we can use AWS DynamoDB. If you want to do any type of real time analytics on your data, uh, where the data is coming on a real time basis, like for any sentiment analysis, ad serving, trend analysis, you can use DynamoDB. So these are some of the use cases where you can use DynamoDB. Now let's see some of the limitations of AWS DynamoDB. It's a very expensive at scale. So it can be more expensive compared to other database solutions, especially when you want to scale the DynamoDB. Uh, it's a NoSQL database, so it's not a good choice for workloads that require a relational database structure. In terms of complex queries, so DynamoDB lacks of query optimizations, and it makes it difficult to execute any complex queries efficiently. So these are some certain limitations of AWS DynamoDB. Thank you.
Welcome to new video. In this video, we will be looking at how do you delete the resources associated with the project once the project is completed. So to achieve this, we will be using something called tags. Let's see what is a tag. So tag is a key value pair applied to a resource to hold the metadata about that resource. So every resource in AWS will be giving you an option of attaching a tag. So tag here is you will be having a key and you will be having a value. Let's quickly see any two resources of AWS. How will this tagging looks like? So I'm going to create an S3 bucket and check how does the tagging looks like. If you click on create bucket and scroll to the bottom, there is something called tag. It says it is optional, but it is very wise for us to add a tag. Always try to add a tag something like project and try to give the name of the project. For example, something like name. We will try to see whether we have tags for other AWS resources as well. Let us try to do it for Lambda. So if I go into Lambda and click on create function, if you scroll down, here you will see something called enable tags, and you need to add a same key value pair which you have added for your S3 bucket. So for each project, try to have a particular key and associated value with it, which you can use to filter out the resources once your project is completed. So maximum you can have 50 tags for a particular resource. So try to have 3 to 4 tags to differentiate based on the need. One is like project, one is according to your resource based allocation or anything for that matter. So once your tagging is done, your project is completed. Now how do you delete the resources with that tag? Go to resource, type resource here, you will get resource groups and tag editor. Once you click on the resource group and tag editor, you will land up into the resource page. Here, click on tag editor and select the region which you want to check for. You can also select all regions and the resource you want to select. Because you are trying to delete the resources associated with the project, it's wise to select all supported resource types. Then you need to select the key which you have given for that particular project and the name of the project. You can select any name like for the project which you want to delete. Let's select real-time streaming over here and click on search resources. Once you do that, all the resources with that particular tag will be lined up in this particular tab. You can select, click on each of the resource, that will take you there, and you can check if it is running. You can delete it. That's how you can sum up all the resources for that particular project, and you can delete one by one so that you are not left out with some resources that are running in the background that costs you in the billing. This is an efficient way to handle your project resources, and you can delete them all at one go. Like you can select everything, and you can also manage the tags and all. So this is an efficient way for you to identify in which region for this project and which resources are tagged. With this, we have come to the end of the video where we looked at how to delete the resources of a project based on the tagging mechanism. This is one way. Thank you.